Hello. Yes. Good evening, good evening, good evening, my dearest J warriors. I hope I'm clearly audible and visible, my friends. So, good evening and welcome. Welcome to what, sir? Welcome to the most important, one of the most important. Yes, let me not hype any chapter by saying most important, because definitely our even JEE Mains paper and JEE Advanced paper, beta, it is segregated in such a way that yes, there may be some high weighted chapters, but the physical chemistry, but rather you will definitely get one, but yes, sometime two questions from solution, and definitely in JEE Advance a very, very, very doable paper. So, good evening, Yash Pratap Yadav. Good evening, HM Hamilton. Hamilton, so a very difficult name, so I would rather say him. Good evening. Now, beta, so the task for today is this chapter of solution and colligative properties. How we are going to target this chapter, beta, we will be just focusing on NCERT, and on the basis of NCERT, let us segregate all the topics also, because we have definitely finished this chapter in our batch, which is Lux JEE in English. And most of my Lux JEE in English students would also be referring to this one shot as a quick revision, because some of them have joined the batch a bit late. So they wanted a quick one shot, and rather I am giving them more than one shot. Why? Because I will be segregating the complete chapter which we have discussed with loads of question practice. But what I have done for this particular session, because as the name suggests, we will be taking NCERT as a reference, and I will personally be uh, dealing with this chapter in such a way that it should become quite applicable. That's a, this is what is there in NCERT and this is what we should do. And definitely, if I give you a percentage beta, then 8 out of 10 times, even in JEE Mains, you will get your straightforward questions, and obviously it will be helping you for class 12 boards as well. Now, but sir, what about the 20%? Even JEE Mains ask few topics which are not there in NCERT. Yes, I'm not saying they are not there, but yes, the practical side of colligative properties, especially those four colligative properties, because they are very beautiful. That's why their application side, which is in a way given in NCERT, but yes, the logical side of it was started, obviously advanced starting that topic, like the topic of ice separation. But yes, after that, I guess after 2024, even JEE Mains have started asking those beautiful topics, and therefore we'll be discussing everything related to NCERT, and then we'll be moving a bit, uh, uh, going to the application side of NCERT as well. So I hope everybody is ready with their pen and copy. Do not worry, I will be telling you this is not going to be just question practice session. If you are practically at stage 0 for solution and colligative properties, still it will be helpful for you. Cool. So let's see who else have joined us. So good evening, Harsh, Mr. Goswami. Good evening, Vishal, Seni. Good evening, Vijang. Then we have Sonali. Okay, Sonali is saying, Sonali, welcome, beta. I hope she used to come in our previous sessions when once we were mentoring those people who were attempting the JEE Mains 2026. So Sonali, okay, she's saying she got VIT Pune. So Sonali, I'm very happy for you, beta. I'm very happy for you. Hope you will be doing great with your career. Chalo. Sir, what will be the duration of this section? Sidvi, it will be, let's see. I'll try to keep it precise, concise, but let's see. Around 3 to 4 hours, beta. I'll try to cover. If we practice more questions, beta, then obviously time can extend, but I will make it a point that I will give you questions for homework also. But yes, I will be discussing few. So if we discuss more questions, then obviously time will increase, but I will try to make it precise. Maximum 3 to 4 hours, maybe 5. Let's see, है ना? Sir, okay. So Charu Vardhan, hello beta. Then we have Vijayank. Vijayank, good evening. Svidvi is saying, I answered that beta. Chalo, chalo. Now, I hope everybody is ready with the pen and copy. So, with that, let us start the journey of solution chapter. But, sir, before starting this, let me just give you an idea, sir, the basic definition, because we are going to give our board's examination also. So, what is a solution? A solution is a homogeneous mixture of two or more, but they should not react. So if we are mentioning it as a solution, then we consider that solution as a homogeneous mixture of two or more non-reacting substances. That means, sir, in this chapter of solution and colligative properties, we'll be only discussing of homogeneous solutions. What are the category of solutions? The solutions on the basis of their states are of two types, either heterogeneous or homogeneous, your class 9-10 basics. On the basis of concentration, they can be unsaturated, where more solutes can be added. They can be saturated, where at that particular temperature sufficient amount of solute has been dissolved in that particular amount of solvent and no more solute can be dissolved. And super saturated, like if you take a glass of water, if you increase the temperature, then more sugar can be dissolved in that particular amount of water. Then you again bring it to the room temperature, then it becomes a sugar syrup, so that becomes a super saturated solution. So that is a categorization on the basis of concentration, and definitely on the basis of physical states. Who decide the physical state of a solution, sir? That component is termed as solvent. So let us quickly define what are solvent. Yes, and if it has two components, so it will be a binary solution. If it has three components, it's a ternary solution or tertiary solution. And if it has four components, it's a quaternary solution, so on and so forth. But, sir, for our JEE syllabus, we only have to focus on binary solutions, because generally we are given a question with binary solutions. Now, what is a solvent? Let us focus on binary solution. So if I'm mixing 1 and 2 components I'm mixing, who will be termed as solvent? That component is termed as solvent who decides the physical state of the solution. That component is termed as solvent who decides the physical state of the solution. And obviously, if the state of two components that you're mixing are same, then who will be solvent? Then you can apply this, that component will be solvent which is present in larger amount, and obviously the lesser amount will be of solute. So a basic example, if I have sugar and water, then, sir, sugar is a solid, sir, water is a liquid. If you mix them, it will be a liquid solution. That means who is deciding the phase of the the physical state of the solution, sir? Water. So your water will be solvent, and definitely your sugar will be solute. A very easy, a very probable topic. I hope everybody can buy this. Now, again, let's say both are in liquid phase, sir. This is larger, this is smaller amount, so this will be my solvent and this will rather be my solute. What else, sir? Sir, let's say I have a solution where I'm mixing 60 gram of sugar, sir, it is a solid, in 40 gram of water, which is a liquid. But, sir, sugar mixed with water, once you obviously stir it, it becomes a solution. What will be the state of the solution? Liquid state. So I am not bothered whether you are more, the hell with your amount. Who is deciding the phase of the solution? Because this will also constitute a liquid solution. That means who is deciding the phase of the solution? This guy. Therefore this will be solvent and this guy will be solute. I hope a very basic idea, but one should know that component is solvent which decides the physical state of the solution. And this is my beautiful NCERT table, which is NCERT table which decides and segregates the types of solution on the basis of physical state. So obviously, if solvent is gas, I will be a gaseous solution. If rather my solvent will be a liquid, so I will be a liquid solution. And if the solvent be solid in state, then I will be a solid solution. So that means solute can be anything. Yes, solute can be gas, liquid, or solid. So you can have three type of gaseous solutions, three type of liquid solutions, and three type of solid solutions. Obviously these examples are not important, beta. They are very, very important. Now let me just quickly browse to NCERT so that we can have an idea that whatever we have discussed till now, why it is relevant, and we'll see that table in NCERT also. But let me just look at those comments first. Sir, suggest a timetable. Vaibhav, if you are actually serious about JEE na beta, your best timetable is, if you are not sleeping, especially if you are a class 12 students, that means you are targeting JEE 2027. If you are not sleeping, if you are not involved in any activities that are mandatory, like you're not bathing, you're not eating, let's say recreational time, talking with your father, talking with your mother, talking with your as in not those great chats of society, but yes, general, to share yourself. So if you're not doing those recreational activities, whatever time you have, just study. It is indifferent, sir. My friend has that much of topic. This guy has done this much of topic. Don't compare yourself. Ultimately, the comparison will be done on the D day. Let JEE Mains paper, let NTA, let JEE Advanced paper, let IIT do that comparison, because they are meant to do that. You don't compare yourself. You compete with yourself. Whatever you are doing on a day one, just try to match that, and let's increase by 1%. So just try to beat yourself, and in while beating yourself, whatever timetable you're following, my friends, because you know why I'm not restricting that, because there are some students who challenge their biological clock, and at the end of the day, if I'm just talking of the JEE results, not afterwards, or else it is bad. But yes, there are some students who challenge their biological clock. They don't sleep in the night, they rather do random sleeping else in the otherwise time of the day, and they are super productive. They are super productive. But yes, beta, once they sit into a JEE Advanced examination, paper one they manage, but paper two they are shattered like anything. Because paper two, sorry, their biological clocks are set that they feel low in the afternoon. Generally, they have their classes in the afternoon. That's why they rely on the person, maybe in the online platform or in a physical classroom environment. They rely on the teacher to read the question. So the main problem they face in while giving their paper 2 for JEE Advanced, they even can't interpret what is given in the question. And that happens with most of the students who challenge their biological clock. So I'm just advising, don't challenge that biological clock. Yes, you prefer reading at night, read at night. But make it a point that it should be till 2, and then you should go to bed so that you can wake up at 6. Yes, sir, but that will only give us 4 hours of sleep. Then take a power nap in the afternoon, 1 hour, 1.5 hours. So whatever suits you, beta. I mean, I am not doing anything on that, whatever suits you. But yes, make sure you are following a strict pattern and follow that throughout. Make a strict discipline, है ना? I hope Vaibhav, because that's a Vaibhavi. So Vaibhavi Hatwar, beta, that's a question which class 12 students, after having that mentality in their mind, their back, that's a setback actually. Sir, my 11th is completely blown, sir. What I'll do, sir? First, first, do not worry, start doing rather than thinking of doing things. So the moment you start doing, no, any and every job will be done with a bit of efficiency, which is best, which is suited for you. It may be not like boy A or boy B, it is best for you. I hope I'm making myself clear. Chalo. So Vaibhavi is saying, okay, if you are in class 11 beta, then you do not have that setback. So shares, I mean, all blessings to you. Start learning. है ना? Sachin Tejas is saying, sorry to ask this, sir. When will you start organic chemistry? Beta, why sorry? We have at PW, we have a regular and strict schedule. So we have in our Laksh batches also, we have started with electrochemistry, solution and colligative properties, electrochemistry, chemical kinetics, and after this chapter, we'll be moving to organic chemistry. But for you people, I have already taken the first lecture of NCERT. This NCERT based series was for alkyl halides, and I have not just given you alkyl halides during that session. I have tried to complete hydrocarbons also, but not the complete hydrocarbon part, but most important part of hydrocarbon I have covered, which is directly used in alkyl and aryl halides. So, Sachin, I hope you have seen the previous live. So, if not, then please go to the live section of PWJ English YouTube channel. You will be finding a lecture with a NCRT in my hands saying hydrocarbons and alkyl halides. So, beta, that is already started. So, kindly refer to it. है ना? Sir, is PYQ enough to crack JEE? Beta, conceptually practicing that PYQ is definitely enough. Why I'm saying conceptually? Some students have an idea of they just learn. Don't learn. At least learn why you are doing it, and then it is good to learn because ultimately you have to be time efficient. So yes, definitely those conclusions has to be there inside your head, which can be used as a bullet whenever you see a questions in front of you, and in a bliss, in a ziffy, in a second, in a frame of 1.5 minute, you can deal with that question, which maybe others can take 2, 3, 4 minutes. So definitely you should understand and learn those formulation, those formulas, but first understand them and then try to learn them, so that if the question is tricking the with the details of those numerical, then it may not trick you, rather you may leave the question and move forward. Yes, after attempting all those easy and moderate questions, you can then come back to those questions, so it will rather become more productive, and then obviously you will be clearing your JEE examination with flying colors, है ना? The concepts are good, but question seems too hard because beta you don't practice much. Concepts are good, that means you must have read the concept, you must have attended the class properly. But now, is attending the class more than sufficient? Then beta, all the students who are going to who are attending offline lectures and going to offline online classes, they are just beautifully maintaining their notes. But is maintaining notes more than sufficient? Then beta, all the students in the class will be getting AIR1. Now the difference is created by the amount of practice you do. The more and more questions you practice, the easier questions start seeming to you. If you expect that you should do all the questions in one go, no. Out of 10 questions after reading theory, you may attempt 6 or maybe 7 or maybe 8, but 2 you will miss. And then you should, but no, don't leave those 2 questions while practicing. Then go through the proper explanation, maybe the video recordings, whatever your teachers, your AI is providing to you. Like PW these days provide beautiful doubt engine facility, so you can very well facilitate it to ask doubt. Rather asking to a teacher, AI becomes very useful and powerful to communicate that particular question explanation to you. But now don't just leave that explanation. Now write that explanation in your class notes, and that will now become a part of your theory. Your it should be there in your class notes, and then those class notes will be so much modified and modulated that once you will be revising the complete chapter with those class notes, no one can beat you, because they have your summarized conceptual understanding also. And now you see, whenever those questions come again, people will face challenge, but you have those questions in your head, and then you just use that gunshot, attempt that question correctly, let's say in 1.5 minutes. Others may, whoever may do it successfully, may rather take 5 to 6 minutes. So that actually creates a difference, है ना? Chalo. Now, sir, why you have brought us to NCERT? Because obviously the initial page of the NCERT is just discussing about the solutions, which we already did. Now the types of solutions. Sir, what are the types of solutions that we have? Obviously, beta, homogeneous solution. Let me just use a marker also. Huh. First, first we have these. Uh, Huh. First, we have these homogeneous solution, and we have definition of solvent and solute, which we just discussed. Then we are going to discuss only binary solutions, because NCERT find interest only in binary solutions. Now, what else, sir? Beta, after this, you have this beautiful table, a very, very important table about the types of solution. Now, what are these type of solution? First is, sir, gaseous solution. So what is a gaseous solution? When you have solvent as gas. So what is the first example of this gaseous solutions? A mixture of oxygen and nitrogen. So because in nature you have air. Air is mixture of gases. Now who will be solvent? Sir, both components are gaseous in state. So nitrogen will act as a solvent because nitrogen is in large amount, and oxygen will be solute. So how you write this solution, how you pronunciate the solution, you say solute in solvent. So this is a solution of oxygen in nitrogen. So make sure you also, because most of the time question do not tell you what is solute and what is solvent, rather they do English, and then word problem creates a difference. So solute in solvent. So example of gas and gas is air. Example of liquid and gases, sir, chloroform in that air. So solid and gases, sir, camphor in that air. Gas and liquid is oxygen dissolved in water, because of because of which aquatic life exists. Liquid and liquid, sir, ethanol in water, whatever the society uses. So solid in liquid, sir, glucose in liquid, or any solid, salt, NaCl in liquid, water. So solid solutions, so gas and solid, very famous example, the hydrogenation that you do. Let me just quickly go to, then let me just show you how I'm maintaining my lecture flow, and after this we will be discussing about the concentration terms, and concentration terms will definitely fetch you one question. Concentration terms will definitely fetch you one question. So let us now move to our slides. Anna, let me just increase the brightness, because NCERT was quite white. This is quite eye friendly, so that's why we prefer a black screen, because that rather comforts your eyes, है ना? So the only reason I have shown you the NCERT before is because I will be maintaining all those concepts which are there in NCERT. So yes, definitely after this lecture you can refer that NCERT, but I will not be modulating that brightness again and again. But I hope now you know how I have structured these notes for you. Cool. Hi, sir, from Laksh English. Okay, Kavyan is here. So Kavyan is our buddy from Laksh English, Laksh J in English. So Kavyan, no issues. You can just, we have just started the basic discussions as per NCERT. Now moving forward. Chalo, chalo. So examples are, sir, solution of hydrogen in palladium. You remember that, sir? Alkene, double bonded carbon, reacts with hydrogen to form alkanes. What catalyst you used to use? Sir, solid catalyst, nickel, platinum, palladium. Now what does that solid catalyst do? That solid catalyst absorb these unsaturated hydrocarbons. After adsorbing, I'm not saying absorbing, I'm saying adsorbing. So what does this adsorption mean, sir? Let's say, beta, this is a solid metal surface. On this solid metal surface, whatever reactants you have, like CH2, bond CH2, I'm deliberately not making that double bond. Why? Because that double bond is obviously going to break. So I'm making it with a dotted line. But this guy, these gaseous molecules are adsorb. What does adsorption mean? So they are collected over the solid catalytic surface, and thereby now these reactants are holded very strongly. And now let's say if I want to hit a person who is huge, and if I get my brother so take over his hands to the back like this, now I have full exposure of that person, and I can kick and hit that person straight on the nose, because the person, my brother, has strangled that particular guy. So similarly, these solid catalysts adsorb. The phenomena of collecting over the surface is called adsorption, and now the reactant molecules can easily attack. That's why the rate of reaction increases. So again, I should not make this bond like this. Why? Because hydrogen hydrogen bond will be broken, hydrogen hydrogen bond will be broken, and these new bonds, C bond H bonds, will be made. And once this CH2 bond CH2 has become CH3 bond CH3, then they will diffuse. They will diffuse as alkane, making the catalytic surface available for another reactant molecules to diffuse inside the over the catalyst and catalyze the reaction. So here, what is present in more amount? Sir, this solid. What is present in less amount? Sir, this gas. So this mixture is known as, sir, gas in liquid solution. So a solution of hydrogen in palladium, platinum, nickel, all are solids. So liquid and solid solution, amalgam of mercury. What is amalgam? Whenever you have mercury mixed with any metal, that is generally termed as amalgam. So mercury mixed with sodium is sodium amalgam. The solid in solid solution, all the alloys that you know are well known example of solid in solid solutions. Cool. Chalo, moving forward now. Sir, you said after in NCERT, after this we had concentration terms. What are concentration terms? They are terms that characterize how you should name a reaction. Sir, what is naming a reaction? Beta, you can't write theory now. I've taken 500 ml of water, added 4 gram of this, density of added solute was this. You can't write all the story. You just need a sticker that mentions the concentration term of a solution when you are using those reagent for scientific purposes or industrial purposes. So in order to give categorization, in order to give name to the amounts of solute added to a solvent, we have defined some concentration terms. Those are the characteristic of a solution. And in order to understand those concentration terms, obviously we are talking of binary solutions in general. So solute added to solvent will form a solution, but in order to just be mathematically easy, I will, whenever I am talking of solute, I will be writing as 2. Whenever I will be talking of solvent, I will be writing as 1 in the subscript. Whenever I will be talking of the solution, let's say volume of solution, density of solution, I will be writing as SOLN. I hope this much is clear because it will help us to do those derivations easily. Cool. Chalo. Now, the first concentration term is percentage composition. Where this percentage composition is used, so this percentage composition is used in mixtures, in solutions like a Maggi packet. Just pick up a Maggi packet. In the description side of Maggi, you will see every 100 gram contains this much gram of protein, this much gram of that, this much. What percentage they are using? They are using weight by weight percent. So what does mass by mass or weight by weight percent mean? Sir, mass of solute upon mass of solution, because we are calculating percentage into 100. So similarly, if you take a Roux Abza bottle, then in that Roux Abza bottle, in the description, it will be written every 100 ml contains, or every 100 ml generally they use as every 100 ml contains this much of milliliters of khaskhas, this much of milliliter of artificial sweeteners, this much milliliter of potassium. Those syrup bottles, they say no that they are energy drinks. So whatever content they are adding in ingredients, they are adding, what percentage term they are using? Volume by volume percentage. Obviously, sir, volume has to be in same unit, so mass has to be same unit, so I have not mentioned the unit. But whenever you take a syrup, let's say you got cough and cold and you took a syrup, cough syrup. Now just read in those pharmaceutical syrups, sir, it will be there will be having a description that every 100 ml contains this much milligram or this much gram of paracetamol, or of some XYZ antibiotic, whatever those biological reaction ingredients are to make you well. So that, sir, technically there are many I mean the complete pharmaceutical syrups. Sir, what percentage term they are using? Sir, they are using mass by volume percentage. That definitely means mass of solute upon volume of solution into 100. But make sure this is not on your wish. You have to put this weight in gram and you have to put this volume of solution in milliliters. Yes, definitely this kg, this gram can be kg, but if you are writing this in kg, then this has to be in liters. Obviously, sir, that thousand will be getting cancelled. So please remember that whenever you are given with mass by volume percentage, mass will be in gram and volume will be in ml. So this is percentage composition. So the same percentage composition can be used the three forms, but for a dilute solution rather than percentage, we are interested in parts per million. Why? Because there are some solutions where even little amount of solute becomes lethal. So for those dilute solutions, instead of percentage composition, ppm or rather ppb is also used. ppb becomes parts per billion. Generally parts per million is more applicable as per NCERT. So what does 1 million means? Sir, we Indians love, we love lakhs and crores. So technically 1 million is 10 lakh rupees. So 10 lakh is 10 raised to the power 6. So instead of that 100, I'm having 10 raised to the power 6. So whatever I will be getting, that will be parts per million. So mass by mass, volume by volume, and mass by volume. Next concentration term is mole fraction. Yes, Ashlesh. So we are having our champions. We are having our champions from Laksh JEE. Ashlesh, welcome. You are late, but never better. Better be late than absent. So welcome. And we are discussing concentration terms. So please participate. And yes, this is going to be a complete revision beta. I will be focused on the complete conceptual side of chemistry in whatever colligative properties we have in NCERT. है ना? Chalo, perfect. Okay, Ashlesh. Good evening. Now, so next concentration term is mole fraction. So again, for a binary solution, you can have mole fraction of solute. Technically, this mole fraction is termed as chi. This is not x, this is chi, but I like calling it x. So x2 is equal to number of moles of solute upon number of moles of solution. Sir, you said solute you can write as 2. So number of moles of solute upon number of moles of solution, which is N1 plus N2. What about mole fraction of solvent? Sir, it will be number of moles of solvent. It will be number of moles of solvent. This is N1 upon number of moles of solution is N1 plus N2. Please remember this. If you add mole fraction of solute and solvent for a binary solution, it will always come out to be, sir, unity. It will always come out to be 1. Cool. Say or give me, beta, please say organic, sir. Organic? Pratap, Gayatri. So beta, I have already started with organic, the first chapter of alkyl and aryl halides coupling up with hydrocarbons. I have done that in the first live. In the first live where we are teaching, where we are discussing the JEE concepts, but alongside following the details of NCERT. So based on NCERT, we are dealing with the concepts, and we have started that with alkyl halides. Please go to PWJ English live. You will be getting that live. This is the second live. This is the second chapter that we are discussing on that series. ठीक है? Pranshu, please tell me name, sir. What name, beta? Acha, your name. Your name is Pranshu Avasthi. Good to know you. Class 11th. What class 11th? Chalo, cool. Moving forward. Now, say organic. Organic chemistry. Said beta. Gayatri said. Chalo. I hope everybody is clear. Now, quickly do this question, everybody. Quickly do this question, everybody, giving you not more but 30 seconds. I definitely know time is not sufficient to attempt mathematically, but yes, at least read the question, and all those who are good with their calculations, you can at least find out the answer as well. So quick, everyone. the mole fraction of NaCl in a solution containing 1 mole of NaCl in 1000 gram of water. So obviously, if you're planning to calculate mole fraction of NaCl, which will be my solute, that means you want to calculate x2. Sir, x2 will be equal to number of moles of solute upon number of moles of solvent plus number of moles of solute. Now, it should contain 1 mole of NaCl, that means sir N2 is definitely 1, and what shall be the denominator? So N1 is definitely water, whose weight is given. So number of moles is equal to weight of substance. What substance we are talking? So weight of solvent, which is water, which is 1000 gram. And number of moles is, sir, weight of substance in gram upon its molar mass. So what is molar mass of water? Beta molar mass of water is 18 grams. So 18 plus N2. So this is just a plus minus and mathematical into divide that you have to do, and once you do, I guess you will be landing at A as your answer. 100%. So Kavyan, great. Chalo. Moving forward, moving to some more concentration terms very quickly. Let us learn their definitions and then quickly jump to the application, that is the numericals. Now, one concentration term is strength of the solution, not used to a larger extent, but yes, you should know. Strength of solution is nothing but weight of solute upon volume of solution in liters. So in symbol, it will be weight of solute upon volume of solution in liters. Now, what is molarity? Capital M of a solution, a very famous concentration term, sir. It is number of moles of solute upon volume of solution. So what is relationship between molarity and strength? Sir, molarity you said is number of moles of solute. So number of moles of solute will be what? Molarity we write as capital M. Number of moles of solute will be N2 upon volume of solution in liters. Now, if instead of number of moles of solute, I write weight of solute, because number of moles is weight upon molar mass. So molar mass of solute is M2, weight of solute is W2. I'm not again and again writing this. Weight of solute will always be in gram, because number of moles is weight in gram upon molar mass. Sir, into weight of solution in liters. And we have seen this in the previous slide, sir, that weight of solute upon volume of solution is nothing but strength. So, sir, this gives us a conclusion that molarity is nothing but strength of the solution, which will rather be S upon the molar mass of solute. I hope everybody is good. So this is just a basic relationship between molarity and strength of solution. Unit of strength will be gram per liter. So unit of molarity will be, sir, unit of molarity will be moles per liter. Sometimes this moles per liter is also written as molar. Sometimes this moles per liter is also written as molar. Now, after this, sir, next concentration term is the small m. This small m is termed as molality. What is this molality? Sir, this is also, numerator is same, number of moles of solute, but in the denominator, sir, I have not volume, I have weight. Not of solute, not of solution, but of solvent. So please remember, students always forget this, obviously, which have less revision. So kindly you revise your content properly. So sir, molality is equal to number of moles of solute upon weight of solvent, and definition says in kg. Now, in terms of symbol, so number of moles of solute is nothing but weight of solute upon molar mass of solute. I beg your pardon, I have not corrected these class notes. Whatever they the printing error they are having, they are still having. Chalo, but let me do it here so everybody can see. है ना? Relationship से याद आया. Okay, Ayush, perfect. Now, oh, I haven't installed. Okay, perfect. Now, So this is weight of solute upon molar mass of solute. This is written in place of number of moles of solute. Sir, generally the weight of solvent that is given in the question is in gram. So if you put this weight of solvent in gram, but sir, by definition we have to put in kg. Beta 1 kg is 1000 gram. So 1 kg is 1000 grams. So 1 gram will be 1 upon 1000 kg. So if you just divide this by 1000, even this gram will become in kg. So that 1000 I have written in the numerator, and I am definitely suggesting you that you should remember this formula also in order to be quick in your examinations. What is unit, sir? Beta, this will be moles per kg, and this moles per kg is also written as molal. So molarity is molar, molality is written as molal, lal. A very beautiful, a very beautiful formula, a very beautiful conclusion about molality and molarity. Among capital M molarity and small m molality, molality is considered as a better concentration terms. Why? Because it is independent of temperature change. That means, sir, because it has mass, and if you change temperature, technically in comparison to volume, mass has negligible effect. So we say if you take molality even in winters or even in summers, the solution will approximately have same value of molality. It will not change much, so it is negligible change. But sir, volume changes with temperature like anything. Sir, as you increase volume, sir, as you increase temperature, volume will also increase. And because molarity is inversely proportional to volume, so as you increase temperature, volume will increase. As volume will increase, our molarity will decrease. So not only molarity, but all those concentration terms which have volume factor in their definition, they changes with change in temperature. Hence, generally in a laboratory, in a industry, you generally don't label the reagents with their molarity. Why? Because you have to do the same job again uh, in the next season. Summers, if you have done the labeling, then you have to repeat that job. Even the reagent is there, but you have to repeat that job because the concentration terms has changed. So rather you prefer molality. Now what happens to molarity, sir? Obviously you said with temperature increase, volume increase, so molarity decreases. That means there is an inverse relationship. I hope you have a very beautiful graphical question also on the basis of this JEE Mains. Chalo. But if you are just confident with the content na beta, you will be able to practice most of the questions. Cool? Chal. Cool. Hi, sir. Ramandeep Singh from Arjuna J. Yes, Raman. I definitely know. Acha, Raman, your name is Rajendra Kumar. Okay, but I know you. I know you are. Come on. Our superstar from Arjuna Ji. I don't know how to make note. Beta, I read that comment. Even I read that comment in the class also. Ramandeep, I read that comment in the class also. The only thing I am telling you, beta, yes, you said, sir, I will take notes of some ex friend of mine. She makes note very good, very beautiful. Be it. Beta, the only suggestion I am giving now, you can, if, sir, there is in order to move from point A to point B, there are multiple ways. There are multiple ways. You will be following this way, beta. This is called my way, your way of doing things. Why? Because once you are doing it, you can't see yourself as a third person. So you will just be doing it, and definitely you will reach from point one point to another point. But because we can virtually see you, by your performance, by your examination results, by your class participation, so as a teacher we can see you as a third person as well. So we can guide you that beta, you are definitely reaching from point A to point B, but you are taking the longest path. Rather, the shortest path will be this, and this is generally highway. So you can follow my way, But I'm definitely suggesting that you, sir, why we, that is not longest part, sir. I will take very less time. I will not even make notes. I will only practice questions. Beta, the concept that you will be writing by your hands now will be there in your head for 2 years. Can you promise me one thing? Can you promise me one thing? Whatever you have written in a copy, you will not forget for the coming 2 years. You may. And I'm definitely telling you, if you do not write by your hands, you will definitely. So actually writing notes by your hands gives you better compatibility, makes a relationship with the content. So in order to make that relationship, it is always advisable to write notes by your hands. But yes, because you are so much adamant in that, sir, in my life I have not done this, then don't do. Then maybe your my way can match this highway, maybe. But yes, there's always a percentage of probability, है ना? I hope that I answered that, beta. Chalo. Sir, that is my old account. No worries. I hope I answered that. Sir, I am also more work to convert kg to volume in labs. Okay, Ashlesh. It is also more work to convert. Okay. But beta, kg to volume you can always do, why, if you know the density of that particular thing. But yes, yes, rather, if you know the density, then that is just mathematics. There is no manual work you have to do, है ना? But yes, ta- pasting those stickers in the reagent bottle will require manual labor also. Let's say if you have 100 of those bottles, so first you have to write in a page, then stick it, then because people will be obviously using it, so you have to again cover it with a plastic lamination. So technically that's a job, that becomes a work. So rather, that's why molality is considered as a better concentration term. I hope everybody is done with this now. Quickly moving to the basic application of questions. Rather, these are some basic questions, but let me just uh, solve. I will be coming to these topics, but let us solve a question of JEE Mains only. Huh? So please attempt this one, beta, everybody. Sir, but you have shown so many questions, but you are directly doing this. Yes, we'll be definitely going to all the relevant questions. We have to be time managers, na beta. So let us attempt a question through which we can understand also something. So quickly, everybody, quickly, everyone. I need answer, everyone. Sir, but may. So Ramandeep, beta, no but. Ifs and but, my ifs and buts are done. Now it is your, I have given you the pros and cons. Now it's your call. So you can do anything. That's your call now. I'm good with either things. Beta, Ramandeep, I hope you remember this. I have said concentration terms part. Remember? I told that in the class also. Concentration terms notes part is even there in class 12th. Ramandeep, remember? Concentration term is even there in class 12th. 50% of your solution in colligative properties, 40% is definitely the concentration term only. हाँ बेटा, welcome, welcome, welcome superstar, welcome. Ankita Pal, hello beta, good evening, very good evening. Then we have Sindhu Chobe. Sir, I'm dropper. I have notes. So do I have to make notes? No, beta, not at all. Just try and learn. Just try and synchronize with the concept and attempt the questions. Let me just see the percentage. I guess answer for this one is Kavyan. Great. Now we have 118 gram of aqueous solution containing 18 gram of glucose. What is the molality? We have to find molality of the solution. Sorry, sir, for my late attendance. Nahi yaar, Ankita, come on. Acha, Ankita. Oh, ho, beta. There is a picture also. Usually, I'm not. Usually, a small picture. I can't see that picture. I mean, from this distance. But usually, I don't. I see your names. No. So, because a picture is there, so I could not relate. Okay. So we have active participation from my Laksh JEE students here. Great, beta. Awesome. That means whatever you have answered in that poll, you are abiding by that. So I'm happy. Great. Chalo. So let's. Hi, sir. Love your explanation. Okay. Rohan Verma. Thank you. But yes, keep learning, keep growing, and then you will be giving us all the good wishes then. So thank you, beta. Chalo. Now, sir, question. Question says, sir, this 518 gram is weight of solution, sir. Aqueous solution. Obviously, water is the solvent. That means, sir, this is weight of solution, sir. Okay, beta. Sir, glucose is the solute, sir. Okay. So weight of solute is 18, sir. Okay. Molar mass of glucose given, sir. So M2 is given. Molar mass we write as M and solute is 2. And molality, sir. Molality is equal to number of moles of solute upon weight of solvent. If this is in gram, then I need 1,000 in the numerator in order to convert this into kg. Done, sir. Now, number of moles of solute is equal to, sir, weight of solute upon molar mass of solute into this weight of solvent. I'm not writing gram now. I wrote here in order to make you understand that 1,000 has to be there in the numerator. Now, sir, I just need these values. Sir, we already know these values. What are these values? Sir, W2 is given, sir, 18 rupees, sir. Sir, 1,000 is 1,000, sir. Now, what is molar mass of solute, sir? That is also given, sir, 180 rupees, sir, into. But, sir, I just need this weight of solvent. Sir, I know weight of solution. Arey, beta, you know weight of solute also. So, weight of solution is nothing but weight of solute plus weight of solvent. Sir, so this is 518. This is 18. So, can you find W1? Oh, come on, yaar. Just do the subtraction. It is 500. That means, sir, this is 1 rupee, this is 10 rupee, this zero gone. Then these zeros gone. So 1 by 5 is definitely 0.2. Now, you will get so many questions, but just you have to understand what is the definition. Now, sir. Now, perfect. Now, perfect. Now, point is 500. A is correct answer, beta. Ashlesh, 500. Acha, you are giving weight of solvent. Okay, perfect, beta. Now, sir, we will do so many questions. Okay, sir, done. Now the point is, there are many questions for you to practice, guys. Hai na? Now the point is, there I'm just discussing the type of solutions, the type of questions. Obviously, we can't do so many questions in just one session, but yes, I'm discussing all the type of questions on the basis of NCERT that you will be getting from solution colligative properties that will do your JEE mains completely. Hai na? Chalo. Sir, let's say I have this solution. Let us practice this with a question only. Let's say I have a solution, what? H2SO4. So let's say this is my H2SO4 solution, sir. This is my H2SO4 solution, sir. What is this H2SO4 solution? Its molarity is given, its volume is given. So, sir, its molarity, let's say, is M1 and its volume is V1. Okay. Now I am adding what? Sir, you are adding water into it. You see the question. Final molarity when we are diluted to 500 ml. So 500 ml is the total volume of solution. How we have received that 500 ml, sir? We have added some water, sir, but it is not written adding water, sir. Beta, it is written or diluted. So what does dilution mean? You are just adding solvent. That means you're not introducing any more solute. So that means you're just adding water. Let's say I'm adding V2 volume of water. So what will be my final solution? Let's say this is my final solution. So what will be the molarity of final solution? So molarity of final solution is M. So volume of final solution will be V1 plus V2. Sir, but moles of solute, whatever moles of solute was here, are here only. Why? Because sir, this guy is just solvent. It is not adding moles of solute. So just do this. What? Moles of solute initially will be equal to moles of solute in the final solution. So what does this, sir, what is moles of solute? Beta, moles of solute initially will be initial molarity into initial volume. Finally will be, sir, final molarity, which you have to find, into final volume, which is V1 plus V2. Now this is there in the question also. How? Sir, see, 65 is the initial volume, 0.5. So 65 into 0.5. But sir, this volume has to be in liter. Okay, divide this by 1000, because I have converted into liter. So this is my number of moles initial. Number of moles final release, or final molarity, I do not know. Final volume, it is giving me the value of V1 plus V2, which is 500, because it is also in ml, so 1000. Why I'm not bothered about that ml, although I've done it over here, but you should not next time bother about it, because this ml and this ml will be getting cancelled. So either you can equate millimole, because milli is ultimately going to be cancelled. So do it. So now this will definitely give you your answer. I hope everybody is clear, guys. And this will rather be 0.065, na? 0.065 will be the value of your molarity. Cool, guys. Siddesh Shukla is saying, sir, could you remember? I need. Okay, Ankita. Nahi, Ankita, I have still mistaken you with Laksh JEE English student. But yes, Ankita, now I recall that. That's why, it was looking relatable. You are there from the from the NEET channel. Okay. So Ankita, what was your result, beta, in the re-NEET? What was your marks? I mean, what is the estimation that you are making? How much marks you're getting? Gully, hello beta. Okay, perfect. Kanipang 9013. Okay. Oi hoy, oi hoy, Netaji is here. So everybody, we always greet Netaji with a salute. So I hope you have done your backlogs, Balaji. Chalo, sir, please put video class 11 standard for JEE in YouTube. Please put videos class 11 standard. Okay, beta. Beta, uh, Shashi Meena, Shashi. Netaji. Shashi Meena, beta, the concentration terms that we are doing over here, na, these concentration terms are nothing but class 11 mole concept, later portion. So we'll be definitely beta. Technically, the reason behind these NCERT based series is because all the students who have not joined us, they are just reading through YT. That's why, in order to cater all those students who are unable to join, we are doing this. And beta, your class 12 syllabus now, it generally have a higher percentage in your JEE mains. For advanced, or more or less 11th 12th is balanced, for mains also, but yes, slightly 12th has higher percentage. So if I talk of chemistry, no, if you read class 12th organic, then definitely you have to understand hydrocarbon and GOC also. If you read D block, and the inorganic analysis, you definitely have to know basics of chemical bonding. If you read solution and colligative property, you obviously have to know the concepts of mole concept and stoichiometry. So actually, if you read class 12th, most of the chapters are done. The only chapters are left for class 11 that has no relevance with class 12th is atomic structure, more or less a redox reaction, but still that balancing thing we do in D block. But still, redox reaction, mole concept, thermodynamics, and equilibrium. Barring these four chapters, you have everything in class 12th again. So that's why we are taking class 12th. Okay, chalo now. Sir, उतनी हिम्मत नहीं आंसर की चेक करेंगे का. Okay, beta, then buy that courage, beta, because ultimately that is going to decide your future. Chalo, no worries. Now moving forward, sir. What about this, sir? Beta, sometimes what you see, let's say I have a solution with molarity M1V1 and another solution with molarity M2V2. And now you have to calculate the final molarity. Sir, what you will do? Beta, calculate total moles upon total volume. What is total moles? So moles from this guy, that is N1, moles from this guy, which is N2, upon volume V1 plus V2. So this N1 will be, beta, calculate this N1 separately because it will be M1 V1. Calculate this N2 separately because this will be M2 V2. And beta, such type of questions also you get directly in your JEE. For example, find out the resultant molarity you have to find of solution. So this is V1. So this is M1. So HCl. It is added with 200 ml of, so another HCl solution with volume this, molarity this, but here you are adding some extra water also. So will this water, it will only dilute, sir. So for this formula, what this formula will become? Sir, moles are only coming from first and second, but volume is also increasing by water. So if you are adding water also, then you have to divide that V3 in the denominator, and then whatever you will be getting will be the value of your molarity. I hope everybody is clear. Okay, Dhanu. Okay, Kani. I got it. Chalo, Dhanu. So welcome. Okay, chalo. Sir, bye. I'm going to physics lecture. Physics? Acha. Okay, guys. Okay. You're having your physics class also. But beta, it will be from 7:45, na? Ha, yes. 7:45 to 9:30. Yes, Balaji. Please continue. प्रकाश शाह सर, मैं नीट की प्रिपरेशन कर रहा हूँ, बट मैं अभी क्लास 11th में हूँ, तो स्कूल और नीट को कैसे मैनेज करूँ? A good question, but a basic one. Manage by practicing content from your learning programs in school. Beta, in school you are going to read what? Physics, chemistry, maths. In your classes, in these online classes or wherever you are studying, you are learning about physics, chemistry, maths. So are they same? Only two chapters, two subjects, maths and what, English, or maybe whatever, maybe Hindi or some other computer science, whatever subject you have taken as the fifth subject. Those two subjects, you are going to only read those two subjects in the school. Rest you are reading physics, chemistry, maths. So just try, whenever the content is delivered to you in the class, practice your questions or take your class notes also along with you, and then utilize and maximize the efficiency beta. So the more you do, the better you become. Hana? Chalo. Perfect. Now I hope everybody is clear. So these again are some practice questions. Yes, some pH calculation questions also. You just have to calculate the final H plus ion concentration. And what is pH? So pH is minus of log of H plus ion concentration. Sir, what will be H plus ion concentration? Sir, whatever will be the molarity. But sir, this guy will give only one H plus. Sir, this guy will give 2H plus. So calculate number of moles here. So this number of moles will be N1. So what will be H plus ion coming from this HCl? Sir, it will be N1 because 1 will be giving 1. So N1 will be giving N1. So ionomoles of H plus. What H plus, let's say molarity into volume will be giving you value of N2, but H plus ion concentration given by this H2SO4 will be twice of N2. Why? Because one molecule is giving 2 H plus. So what is H plus ion concentrations are total moles, which is N1 plus twice of N2 upon, this is sir moles, concentration is moles upon volume. So upon V1, which is 200 plus V2, which is 400. But so this volume is in ml. So I told you, this is also milli, this is also milli. Milli will be getting cancelled. So why you are bothering? Just do this. So you will get H plus ion concentration minus of log of H plus ion concentration will give you the value of BH. So question relating concentration terms also, and I guess with this you will be getting option 2 as your answer. Now yes, into divide is definitely required, but this is what you have to practice back at home in your class notes, in your practice copy, hai na? Chalo, moving forward. Again beta, same questions you get over and over again. Same questions you get over and over again. This we already discussed. Now one more. Sir, very important beta, this is even an NCERT solved example and obviously a JEE questions and very famous type of, if you just do this type of question and you will be amazed. Sir, what? Beta, here you are given with, acha, I'm asking everybody to at least attempt it once. So at least give it a shot. At least giving you 1 minute. Because yes, very easy also if you know it, but very crucial also as a concept. So at least read the question once. Everybody. Ashlesh is saying 1 gives 2. Ah, beta. In case of H2SO4, 1 gives 2. But in case of HCl, 1 gives 1. So N1 will give N1. But N2 will give twice of N2. Because H2SO4, 1 molecule of H2SO4 gives 2H plus. Cool, Ashlesh? Chalo. At least attempt this, everybody. Beta, you have to download PyLens. Dhani, there's a app called PyLens. You have to download that PyLens to attend the poll. PyLens app. PyLens app. Chalo. Time is done. Answer is definitely option 2. Let me check. Bombay is your answer. Hey, Kavyan, you are doing great. Chalo beta. Let us check why is it so, sir. Beta, let us do it with common sense. Because obviously you can do those derivations also. But here I'm only discussing common sense. What is that common sense, sir? Beta, if I have this glass full of solution, let's say the basic example I always take is mango shake. Yes, Ashlesh, great beta. Perfect. Perfect. Ashlesh is giving more precise answer. 2.7986. Yeah, my dear friend. Yes, my dear calculator. All God bless you, beta. Because these calculations, the more you do, the more the more perfection and confidence you get, and that confidence will increase the speed. Student ask, sir, how to increase speed of calculation? You don't increase your calculation speed by wishing a speed will increase or learning some tricks and you must have seen those, na? Matlab, that is great. Even I, but I get so much of fun by looking at those people. Yes, what is that? UC mass, hai na? So a great thing. I'm the only thing because that thing creates. I mean, okay, no, I'm not laughing. Please, or people else are. Chalo, hey, quiet. We I didn't say anything. Delete. Now, what Ashlesh is doing right now, that the more and more you try to practice, gradually, the more and more you try to practice, gradually, you gain a habit of always being correct. So once you are always correct, na beta, gradually the confidence of you being correct so many times increases your speed of doing those calculations. So just try to be accurate most of the time, in fact all the time, and then gradually after practicing more and more your speed is going to increase like anything. Spider-Man method. I think that is UC Masna. They say this is 1 2 3 4 5 or something like this, and nahi, nahi, something like this, and this becomes the 10th. So 10, then 11, 12, like this. I mean, concept is good. Concept is great, but chalo. Are yaar, I have brought that water glass. Yaar, come on. Hey, chalo. Now, beta, what is this? Let's say I have this glass full of mango shake. Let's sip. It's not there. Let us assume. Okay. Sir, it is sweet. Okay. Now let's take this much small cup of mango shake. Sir, both of them will taste the same, will have same sweetness. If the source of let's say I have a bigger bucket, I've taken out one glass of mango shake and I have taken one cup of mango shake. So beta, what is concentration term? So the amount of solute with respect to the solvent that you have taken. With respect to the solvent, you have taken more mango shake. With respect to solvent, you have taken less mango shake. Sir, but mithas, the sweetness is same. That means sir, concentration as in the amount of solute in the solution is same with respect to the amount of solution or amount of solvent. So concentration terms, sir, so the sweetness do not depend upon what amount you have taken, sir. So the sweetness is same. That means concentration terms, all the concentration terms definition you know will be same. But yes, if you fix your amount of solution, then this will have some specific amount of mango shake, some it will have some specific amount of calories, it will have some specific amount of solvent, it will have some specific amount of solute, then do all the calculation for this. So choosing this amount of solution with our ease, with our ease as in with our mathematical comfort, can make such questions very easy. How? What concentration term you are given over here? Sir, we are given the concentration term which is molarity. What is definition of molarity? Molarity value is 3 and definition of molarity is number of moles of solute upon volume of solution in liters. Okay, sir. So that means now you take a glass of solution and you are free to take whatever amount of solution. So I am taking a solution where I am killing this variable. So if I kill this variable, how will I kill this variable? Take this as 1. So if I take a solution where volume of solution is 1 liter, I have taken this solution only. But what amount I have taken? Sir, it is my choice. I have taken a glass full of this solution where the solution is how much amount? The volume of solution is 1 liter. Why I have taken 1 liter solution? Because it is killing one variable. And now if it is a 1 liter solution, then because denominator is 1, so I directly know the amount of solute it has. Sir, it has 3 moles of solute. Done, sir. I have killed a variable and it has 3 moles of solute. And what I need to calculate? Sir, you need to calculate molality. So molality will be equal to number of moles of solute upon weight of solvent. If I want this weight of solvent in gram, then I shall definitely divide 1000 in the numerator because this will convert into kg. Sir, this though you already know. But now I will do all the calculation for this. For this solution, I will find molality. That will be molality of all the solution from which I have brought the solution. Because concentration term do not depend on amount. But once you have fixed the amount, then do all the calculation for this amount. Because 3 moles of the solute is present in this much amount of solution only. So because you have taken number of moles of solute is 3, so now you have to calculate weight of solvent in this jar. Solution is 1 liter. What is solvent? So let us look at the data given. Now density of solution is this. Now this is not density of solute, this is not density of solvent, this is density of solution. Density of solution is given as 1.25 gram per ml. So because I know density of solution and because I know volume of solution, so that means I can calculate mass of solution because mass equals volume into density. Volume of the solution is 1 liter, but I have density in gram per ml. So rather volume I write as 1000. So 1000 ml into density is 1.25 gram per ml. So ml gone. This is gram. That means this is 1250 gram. Sir, still job is not done because you know weight of solution. I need weight of solvent. Why not done, beta? Solvent will be equal to weight of solution minus weight of solute. Now job is done. No, sir, still not done. Okay, beta, let me check. Upon weight of solution, you know how much? 1250. But sir, I do not know this. Nahi beta, you know this. Why? You know moles of solute. Moles of solute is weight of solute upon molar mass of solute. So in order to calculate weight of solute, this is moles, which is 3. multiply it with molar mass. Solute is NaCl. So molar mass will be 23 plus 35.5, which is 58.5. Now you just have to do that into divide, which our beautiful friend, which our handsome friend Ashlesh has comfortably done till 4 places of decimal. So now you will do calculation and you will see it is 2.79. Everybody good? So thank you for your series. Thank you, Yahoo. I mean, because you are getting benefit out of it, so I'm really happy. At PWJ English Beta, we always had this agenda. We are not we are not out for numbers. We are not at all out for numbers. We are out for helping students. You can see that we are not at all out for numbers, and no matter we have started this channel, we as a team have started this channel from zero on the month of October previous year. And I am very, very honored to say that yes, we have helped and touched so many lives of students. And I am very, very, very proud of all those students. I am not saying they have scored AIR 1. I am, sir, each and every one of us know it does not take any effort to teach a topper. If I am a topper, I can even learn from my class, from my books, from the references. Understand this. It is very easy to teach a person who is already at a good level. Sir, difficult thing is I can be even better than that person. The only reason is I have some drawbacks. I was not knowing, I was not conscious enough. There were no people who were guiding me, directing me, or else I had some environment of friends who have dragged so much of time, extracted so much of precious time out of our lives, that because we are in a tender age, so we got extracted. But now we are vigilant, sir. We want help. So for them, at least we are here, and with those comments, Yahoo, that boost, even after seeing these numbers, those boost always kicks us as a company also, as a educator also, as your mentors also. And thank you, beta. Chalo, moving forward. I hope everybody is clear. Now, next. Again, beta, same type of questions. Now I did one question and I'm telling you same type of questions you get again and again. So I will be giving you these questions. Just attempt these questions and you will be feeling like anything. Chalo. So let me just quickly browse through these questions. You will be getting these questions, beta. No issues, no worries. है ना? So there are not one, but all the probable questions I have taken over here. But yes, we want these will be your homework, beta. Big fan. One over one over one over all. Okay, thank you. Chalo, beta. So I will be giving this PDF. You can also download this PDF for free. Where you can also download this PDF for free. Where just go to PW JEE English WhatsApp channel. The the link to the WhatsApp channel is given in the bio of the channel also. And once this live is done, you can go to that WhatsApp channel and download all these class notes, because I have given you practice questions also. I'm discussing few, and then you have to apply the same logic and you will be practicing more and more. है ना? Chalo. Sir, is this question session? No, beta. We are discussing, Dhanu, everything. Questions also, logic also. So it is Dhanu, it is questions also, but yes, logic also. So why you skipped so much of questions? Because they are very important, but yes, you have to practice them, because I have to now move to colligative properties also. Okay? Chalo. Okay. Thanks a lot. Okay, beta. Thank you, Parth. Thank you, Ankita. Chalo. Now, sir, some important relationships. Sir, can we derive this? Obviously, we can, but I am suggesting that you should keep these bullets in your pocket as a conclusion. Sir, if you are given molarity of a solution, and if you are given weight by weight percentage of a solution, and you're given density of the solution in gram per ml or gram per cc and molar mass of solute, then how they are related? M is equal to percentage into D into 10 upon molar mass of solute. You can obviously derive it, but please, there are important relationships. Why I'm saying important? Because you directly see questions in JEE Mains. Next, density of a solution is equal to molarity, which is capital M, whole into 1 upon small m plus molar mass of solute upon 1000. Sir, beta, common sense I've already told you. Common sense I've already told you, but yes, for students who are well comfortable with their content, please learn these formulas also, because they can act as a gunshot during the time of mains examination. Why? Because they will be directly offering you questions on the basis of this interconversions. Cool. Now, molality of a solution can be represented in terms of mole fraction. How? X2 into 1000 upon x1 m1. X2 into 1000 upon x1 m1. And molarity can also be expressed in terms of concentration terms, in terms of mole fraction, as x2 into 1000 into d upon x1 m1 plus x2 m2. Because this complete derivation also has came as one of the question in JEE, so let us now derive this. At least one we should, because this is the last relationship, so let us derive only this. Now, sir, what is molality, sir? Molarity, sir. Beta, formula of molarity is number of moles of solute and volume of solution in liters. But sir, if I'm putting in ml, then beta, you have to multiply this 1000. Done, sir. This much we know, sir. Now, sir, but here density of the solution is there. So, sir, we also know mass equals volume into density. So, volume will be equal to mass of solution upon density. That density will go in the numerator. So, density of the solution we simply represent as D. But we should remember this, that this D is density of solution, not of solvent, not of solute. And what will be unit of this density is a gram per ml. Why? Weight is in gram and volume is in ml. I hope everybody's clear now. After this, sir, then beta, what is solution? Can anybody tell me what is solution? Sir, solution is solute and solvent. So instead of weight of solution, you can write weight of solvent plus weight of solute. But sir, I want a relationship in terms of number of moles. Then just use that class 11th or class 9th basic formula of number of moles. Beta, number of moles is equal to weight of that species upon molar mass of that species. Number of moles is equal to weight upon molar mass. Yes, capital M we write for molarity. So this is not molarity, this is molar mass. Sir, so if you want, let me again write this formula. So, sir, molarity is equal to N2 into 1000 into D. Whole upon. This is numerator. Now what is denominator? Sir, W1. W1 can be written as what? Sir, weight is equal to moles into molar mass. So W1 will be equal to moles of solvent into molar mass of solvent. Plus W2 can be written as some moles of solute into molar mass of solute. Now, how does this helping me? Beta, just now remember and I'll try to recall the formula of mole fraction. What is formula of mole fraction? Formula of mole fraction is mole fraction of solute is number of moles of solute upon total moles. Mole fraction of solvent is number of moles of solvent upon total moles. Mole fraction of solute is moles of solute upon total moles. Beta, what I have done mathematically, I have done nothing, because if you do the same multiplication numerator also and denominator also, mathematically this is nothing, sir. This is just getting cancelled. But technically it is bringing us to the formula. This N2 upon N1 plus N2 is nothing but X2. This N1 upon N1 plus N2 is nothing but X1. This N2 upon N1 plus N2 is nothing but X2. So that means we have derived the formula. Molarity is equal to x2 into 1000 into density upon x1 m1 plus x2 m2. I hope now you can definitely derive all those derivations. I mean, it is nothing, but still, please remember this, that you should learn these conclusions also, because these derivation, if you do in your examination, it will take time. It will take time. Cool. So Vijyank is saying, sir, confusing. So beta, definitely you can ask whatever doubts you have. Let us wait. Let us everybody, if you want, you can write this also, because that's a good explanation of, because we have seen so many derivations. So everybody, quick, any doubt? Anybody, any doubt? Vijayant, you can ask. Okay, chalo. No, sir. Dhanu is also saying. Okay, perfect, guys. So let us move forward. Sir, can you tell me what's the duration of the class? Beta, after, uh, let's say, we'll finish around 3 hours, 3.5 hours, because after this, I'll just be starting colligative properties, and colligative properties are just basic 4 formulas. And then, yes, definitely we'll be discussing those other things also, which osmosis, which senior approach is saying. So we'll be discussing everything. But yes, beta, it will take, sir, what is osmosis? It will come, beta. It is a fourth colligative property. It will come. Cool. Chalo. So let's move forward. Ha. Chalo. Let's move forward. So that means now we know these concentration terms, and for all these concentration terms, beta, you have so much of problems that I've just shown you. Just download these notes after the lecture. Now, quickly moving to concentration terms. Now quickly move. So please teach class 11th also. Yes, beta, we will. Definitely, I told you. Yes, Ankita. Pi is equal to ICRT. That's the formula of osmotic pressure. The guy is asking, senior's approach is asking osmosis. So that is osmotic pressure, not osmosis. है ना? चलो. Now, uh, sir, teach class 11. Definitely, beta, I told you. We will. We will. Uh, Colonel Tripura. We will, beta. But let us at least first finish class 12th. है ना? Now, beta. Next point that we are making from here is we are moving to the first colligative property. What is a colligative property? I'll discuss it. But sir, why we are moving? Because we need to first explore some common sense. What is that common sense? Given in NCERT. Given in NCERT. Acha, sir, normality and formality. Beta see, Kavyan, chalo. Just one thing, let me add, because Kavyan is asking and I can't. Chalo. So basic revision, beta. Beta, formality is nothing but number of moles of solute you write in case of normality. So this is just weight of solute. Formality is nothing but weight of solute upon, instead of molar mass, for ionic compounds we don't say they have molar mass. Why? Because for ionic compounds, there the formula, the molecular formula that they have is their molecular formula, which decides or which signifies the effective number of atoms present in that ionic crystal. So there, for ionic compounds, instead of molecular formula, saying molecular formula for those ionic compounds has practically no relevance. You should call that as formula mass, because they have a formula unit. So the molecular formula of NaCl is NaCl. That why the molecular formula of NaCl is NaCl, sir? For ionic compounds, na, actually what happens is, because we the chapter of solid states is deleted from our syllabus. So let me just give you this example and get done with this. Actually, generally, sir, we know cations are small and anions are large. So, and we know, sir, ionic compound exists as a solid. So once this NaCl exists as a solid, sir, the solid will be a solid arrangement. So we cut out a unit cell. The unit section, a unit cell is like a brick. That brick, once repeated over and over again, can form the entire solid lattice of NaCl. Now, what is that one brick of NaCl? Sir, the anions, which are these chloride ions, they are present at the corners of the unit cell, of the brick, of the solid arrangement. Obviously, this Cl minus will be a spherical species. This minus is getting attracted with Na plus, but this sphere I am representing by its center of mass. So how you form a cube, beta? This is how you form a cube. So at each corner, what I am having, sir, at each corner I am having these chloride ions. Now, but sir, why minus minus is together? Beta, minus minus is not together. We have voids. What are voids? Interstitial site. In that interstitial side, you have these small cations. Who are these small cations? Na plus. And actually these Na plus are keeping those Cl minus together. So plus and minus is attracting and appearing as a solid. Now, where these Na plus are present, they are present at each edge centers. They are present at each edge centers. They are present at each edge centers. And at the body center also. So somewhere here. And because of this plus minus attraction, they are together. Now, in this unit cell, sir, but if this chlorine is a complete sphere, then this unit cell will not get the complete sphere. No. So what is the effective number of these atoms that are present here? The effective number of these atoms, let us say for chlorine, let us just do this for chlorine. So for chlorine, sir, this is a corner atom, sir. And how what corner, what if it is a sphere, sir, it will be there in this room also. Let's say I have a corner, so this corner will be there in this room also, next room also, in the room to the back also, in the room to that back also. But sir, that will be half of the sphere, half of the sphere in the next floor. So one sphere will be covered in how many rooms, sir? 8 rooms. So this one room will get what share of this, sir? 1/8. So effectively for these Cl minus, effectively for these Cl minus, acha, they are at corners also. These Cl minus are at corners also and at face centers also, beta. So they are also present at the 6 face centers. So we have to learn this. Yes, beta, you should have to learn this. But yes, where? In class 12 solid state, because solid state has been removed from this label of JEE Mains. So, but sir, still why you're telling it? Because beta, I will be then you will be then more familiarized with an idea that why for an ionic compound we don't say molecular formula, because saying molecular formula has no relevance. So let us conclude it quickly that Cl minus are present at each corners and at each face centers. Na plus are present at, sir, at each edge centers and body center. Now, sir, what is the effective number of Cl minus ion present, sir, in this one cube, sir? So this Cl minus ion is present at 8 corners, but each corner will have what fraction of that chloride ion, sir? 1/8. So the one which is at the phase center. So if I have one atom here in this phase center. So sir, half of the bulge will be in this room, half of the bulge will be in that room. So that means one complete spherical atom will be present in spherical species, not atom, they are ions. One spherical species will be here, half in this room, half in the room behind this. So what fraction is coming in this one? So one is in two rooms, so one will be getting half of it. So half of, but how many phase centers I'm having, sir? 6. So you tell me what is the effective number of chloride ions that you have in one unit cell. Sir, this is 1 and this is 3. So 3 plus 1 is 4. Similarly, for Na plus once you solve, sir, body center will completely be there in this unit cell only. And what about edge center? Beta, each edge will be participated by 4 rooms. So one room will be getting 1 by 4th. How many edges I have, sir? 12. So 12 by 4 is 3. 3 plus 1 is again 4. So actually the formula unit, what is the effective number of Na and Cl ion present in this unit cell? So effectively 4 sodium and 4 chlorine are present. But sir, 4 and 4 is stoichiometrically getting cancelled. So this is, so actually that's why we write the simple formula unit. So this is actually formula unit. This is actually formula unit. This is just irony that sodium as per inorganic chemistry is Na plus, so you have plus 1 and minus 1, so coefficient. Actually this is 1 1 because in nature their ionic solid, that ionic crystal is having the formula unit of NaCl solid as NaCl. So technically calculating mass of this NaCl and saying and giving it a nomenclature of molecular mass is theoretically and conceptually incorrect. So for such ionic compounds, instead of molecular mass, what mass we say? We say formula mass. So formality will be weight of solute upon molar mass of solute. Technically it is molar mass only, but nomenclature wise for an ionic compound you should say that molar mass is the formula mass, that is number of moles of solute into volume of solution in liters. So that means this is nothing but normality. Yes. So formality is nothing but formality is actually formality is actually molarity only, but molarity of what? Molarity of those solutes which are perfect ionic crystal. I hope everybody is clear. Now, marinated, sir. Okay, Dhanu. Now, next thing which Kavyan or I guess Ashlesh asked is the next concentration term, which is normality. Generally, beta, normality is nothing represented as capital N. The numerator is number of gram equivalent. Number of gram equivalent of what? Of solute upon volume of solution in liters. Now people will say, sir, what is number of gram equivalent? Beta, number of gram equivalent of solute is nothing but weight of solute upon equivalent weight of solute. So what is equivalent weight of solute? Obviously this is just the same. This volume of solution is just the same. Now, what is this equivalent weight of solute? Sir, equivalent weight of the solute is nothing but this equivalent weight of the solute. This equivalent weight of the solute is nothing but the molar mass of solute upon valency factor. That valency factor I am taking here. And now I am just making you realize this formula again. This is nothing but normality. Sir, weight of solute upon molar mass of solute is number of moles. Number of moles upon volume, sir, that means this is also nothing but molarity. So normality is nothing but molarity into valency factor. Similarly, number of gram equivalent is nothing but this is number of moles into valency factor. So if you just try to find out what is number of gram equivalent of solute, it is equal to number of moles of solute into valency factor. because this denominator is just the same. So ultimately, sir, what is this valency factor? Beta, for acids, valency factor is number of H plus given. For bases, valency factor is number of OH minus ion given by the per unit of that acid or base. For a salt, valency factor is the total charge on either cation or anion. Cation anion charge is obviously same, that's why salt is neutral. But for a normal salt, if a salt is doing a redox reaction, then the number of electrons it is transacting per unit of that particular oxidizing or reducing agent. So sir, for that we have to know the redox reaction. Yes, so that's why generally this normality thing is discussed once we are discussing redox reaction, not otherwise. But still, I hope I have done the justification. Kavyan, cool? Kavyan, cool? Chalo, moving forward. Now, what else after this? Now beta, let's do one thing, because this is already around, we started at 7, no? Around 7. Okay. So let us do one thing. Let us take a 15 minutes break. Okay? And then we'll be directly starting with colligative properties. Let us take a 15 minutes break, and then after that we'll directly start colligative properties. So this is 8:50. So let us meet at 9:05. So let us now meet at 9:05 p.m. Cool? Chalo. So just refresh yourself and come back. But please come back. Just refresh yourself, have those refreshments and all, and then definitely come back. Okay? Chalo. Bye bye. I mean, come, can't see you in 15 minutes. Yes, guys, so I am back. I hope everybody's back too. So, welcome back. Good evening, good evening, good evening again. Let's come back, everybody, and give me a confirmation that I'm visible and audible. Am I visible and audible, everyone? Just give a confirmation. Yes. So, chalo beta. Let's start. And now we will be starting with directly the main area of colligative properties. Now, what is a colligative property? So, all those properties, I mean, colligative properties are just a experimental tool, and all those properties are called colligative properties, where which only depends upon the amount of solute with respect to solvent. If you have a solution, all the properties that only depends upon the amount of solute are called colligative properties. Point number one. Now, what is point number two? Point number two is the first colligative property that is of most importance for us is relative lowering of vapor pressure. The first colligative property that is important for us is relative lowering of vapor pressure. Now, in order to understand that, let us first understand what is vapor pressure. Now, let's say I have this liquid. I'm not saying it is boiling. Boiling is the temperature at which the pressure exerted by the vapors of the liquid becomes equal to atmospheric pressure. I'm not talking of boiling because boiling is a bulk phenomena. Boiling is a bulk phenomena where the complete bulk of the liquid, after gaining that temperature from the excessive heat that you give while boiling, because heating, once you keep on continuously provide that heat, the liquid is tend to boil. But at every temperature, I'm not saying at boiling point. Boiling point, I'm again repeating, is the temperature at which vapor pressure of these gaseous form of this liquid becomes equal to atmospheric pressure. This vessel is closed and I have not used any cooking or heating device. So let's say this is at some temperature T, any temperature T. At that temperature T also, beta, equilibrium will exist. What equilibrium? Let's say this is H2O. So this H2O liquid, first, sir, this will go in gaseous form. That is evaporation. So I am talking of the surface phenomena. Those molecules at the surface will be having some kinetic energy. Why? Because at a particular temperature T, you will definitely have some kinetic energy, and because of that kinetic energy, evaporation will take place. What is evaporation, sir? H2O liquid turning to H2O gas. This is evaporation. Sir, but the moment, because these gaseous molecules will be having kinetic energy, they will also lose their kinetic energy because of the motion, and they will also start condensing. Yes. So gradually, once they will start to increase, they will lose energy and they will undergo condensation also. So I am talking of the process of evaporation and condensation which happens at each temperature T, at all temperature T. Now, sir, a time will come when equilibrium will be reached. And what is that equilibrium time? Where rate of evaporation, initially rate of evaporation will be maximum. But at equilibrium, which will definitely be maintained at that particular temperature T, rate of evaporation, acha, initially rate of condensation is zero. But at equilibrium, at that particular temperature T, this is already written, so let me not make your notes which I'll be giving you. Just go to PWJ English WhatsApp channel. So at equilibrium, at that particular temperature T, rate of evaporation is going to become equal to rate of condensation for all liquid forming their vapors. This is not valid for only water, for all liquids. And sir, at equilibrium, what you can write? Sir, at equilibrium, we can use the measurable quantity. So what measurable quantity you can easily measure for a gas? A pressure. So let's say this is there in a vessel, and at that particular temperature T, I can calculate the value of equilibrium constant in terms of partial pressure. So that will be Kp. And that Kp will be, sir, partial pressure of product upon partial pressure of reactant raised to the power stoichiometry. So partial pressure of hydrogen gas raised to the power 1 upon partial pressure of H2. Sir, liquid will have no pressure, sir, in comparison to those gaseous molecules. Yes. So rather, don't write it. That means the partial pressure of these vapors are not at all dependent upon the amount of liquid that you have taken. Why? Because the partial pressure of these gases, sir, which is at equilibrium, they are saturated. As in, what does saturation mean? You can have no more gaseous molecules, because at equilibrium concentration and pressure becomes constant. So the partial pressure of vapors exerted by these liquids at that particular temperature T is equal to equilibrium constant K, and we know K do not depend upon the amount of liquid taken. So even if you take this much of liquid, even you take this much of liquid, or even you take ocean full of liquid, if the temperature is T, then the vapor pressure exerted by the vapors of that particular liquid, whatever be its amount, yes, it should be sufficient enough to create so much of vapors which can be saturated. So obviously if you have less, very very less liquid, then obviously, sir, equilibrium will never be reached, because you have not reached a point of equilibrium, because you need rate of condensation to become equal to rate of evaporation. So for that you need that limited amount of liquid. So considering this is that limited amount of liquid, then the pressure exerted by vapors of these liquids is not at all dependent upon the amount of liquid that you have taken, sir. It will be always constant, because K is always constant. If you change temperature, then only K will change. I hope everybody is with me. Now this is how we have defined vapor pressure, pressure exerted by the vapors of the liquid. So maximum moles of vapors at particular temperature T, and this volume. I hope everybody is clear. Sir, now because we know vapor pressure, we definitely know, sir, those liquids which are having very high intermolecular force of attraction at a particular temperature T, they will form less vapors because they are attracted too much. And those liquids which are having less intermolecular forces of attraction will form more vapors at that particular temperature T. So that means every liquid forming vapors at any particular temperature T also depends upon the intermolecular attraction extent of the liquid. I hope everybody is clear. I hope everybody is clear. Chalo. So now this is a beautiful example to give you the same logic. Sir, here you have saturated vapor pressure. Sir, here the vapor pressure is, this is not saturated. Why? You can see the crowding is also less. And here also you have saturated vapor pressure. Now what is this telling you? That here this was unsaturated, but because I have decreased the volume, let's say it is a movable and massless piston. So let's say if the piston was at this height, the moles were less. That means the equilibrium is still not reached. So this will not be termed as vapor pressure. But once I have reduced the pressure, the free volume, if I have reduced, then only that amount of moles of gaseous molecules are sufficient enough to reach where, sir, because if you decrease volume, pressure will increase. So this pressure must have again become equal to the vapor pressure, that is the value of K. So what is saturated vapor pressure? Saturated vapor pressure is that pressure which is the value of equilibrium constant K for what reaction? For rate of evaporation becoming equal to rate of condensation. So for this particular case, let us solve this beta. Quickly give me an idea. Okay, no pole. You tell me. There are 3 containers kept at particular temperature T, and in container 1, let's say this pressure is P1, in container 2, let's say this pressure is P2, in container 3, let's say this pressure is P3. Now you have to tell me which of the following options are correct. It is multiple correct. It is multiple correct. Now you tell me which of the following options are correct. Everybody. In the comment section. Everybody. In the comment section. This is a multiple correct question. Let us see how many of you know what is actually vapor pressure now. And the basic theoretical definition, that what is unsaturated pressure. Unsaturated as in moles of gas is less. Quick, everybody, I need answers. Whoever is there with me. Quick. Kavyan, Mr. Expert, Seniors Approach, Dhana, everybody. Chalo, let me solve this for you. Sir, P1 is equal to P2. What is P1? Sir, this is saturated vapor pressure. That means it will be equal to equilibrium constant K. Sir, P2, no sir, it is unsaturated, sir. This will be much less, sir. So definitely option 1 is incorrect, sir. Now, P1 is greater than P2. Yes, sir. This pressure is less because there are less number of vapors. This is unsaturated, sir. So that means P1 is greater than P2. Definitely correct. P3 is greater than P2, definitely correct. P1 and P3 are equal. Yes, this is also saturated. That is also saturated. That means this is also equal to K. Although this volume is less, although this volume is more, sir, because volume is increased. So there must be more molecules that has came over here, which has made the vapor pressure equal to the value of K. So that means P3 is also equal to P1. I hope everybody is clear. Kavyan is saying 2, 3, Kavyan 4 also. Just make sure. Give me a yes. Give me a yes. Everybody. Because this is important beta, or else you will not be able to understand RLVP. The moment you understand RLVP, every colligative property, elevation and boiling point, depression, freezing point is done. Perfect. 2, 3, 4. Great. That means, sir, this is done. Now, moving forward. Moving forward. So let us conclude this vapor pressure quickly. Sir, in order to conclude this, what we need is, first thing is, vapor pressure of a pure liquid is only dependent upon temperature. Yes, sir, because it is equal to equilibrium constant K. Next. Irrespective of the amount of liquid and shape of container, vapor pressure is constant at particular temperature T. Again, these theoretical statements I have written because JEE loves them like anything. Gamersmith, I'm again discussing that only beta. Just try to come in sync. That because the value of vapor pressure, gamer saying, I'm again telling you, because the value of vapor pressure of all liquid at that particular temperature T will be equal to equilibrium constant K. So they, sir, like K, they will only depend upon temperature and they will not depend upon whatever amount, shape. If I would decrease the piston volume, increase the piston volume, sir, if equilibrium is reached, then it is equal to value of K, which is not at all dependent upon the amount of liquid also. So yes, but liquid has to be sufficient enough. If you have less liquid, then you have not reached to a point of equilibrium. So obviously vapor pressure won't be reached. And last but not the least is vapor pressure only depends upon temperature. But how? This is important beta. This is exponential. Why exponential? Because generally we know pressure and volume for a gas is constant. So generally we think that PV equal to constant can be applied, which says that P and V are inversely related. So that means you will feel that the pressure, as you increase temperature, pressure will also increase linearly, because if volume is fixed, then you feel PV equal to nRT. So if moles and volume is fixed, then you feel temperature and pressure has linear equation. They are if you increase temperature, pressure will also increase linearly. No, because here pressure depends upon K. Pressure is exactly equal to K. And for equilibrium constant K, what is the relationship with temperature? Sir, log of equilibrium constant K at higher temperature K2. So instead of equilibrium constant K, I have written the pressure, vapor pressure P. So vapor pressure at temperature T2 upon vapor pressure at temperature T1 will be equal to delta H, which is the enthalpy change of that reaction, upon 2.303 R into 1 upon T1 minus 1 upon T2. That means that this is an exponential relationship. That means it is logarithmic of P is equal to is proportional to 1 by T. So obviously proportionality is inverse. But how the if you increase temperature, pressure, in fact proportionality is direct. If you increase temperature, sir, pressure will also increase. But how? Sir, exponentially. What is the basic idea about around this rule? So this is a direct outcome of Van 't Hoff equation. What does Van 't Hoff equation tell you? That ln of uh, no d by dt of ln of k, which is equilibrium constant, is equal to delta h upon rt square. And obviously once you integrate it, put dt over there. So let me do this for you so that you can get this equation, because this is an outcome of equilibrium. This is outcome of chapter of equilibrium. So d of ln of k will be equal to delta h upon r into 1 upon t square dt. So once you integrate it from temperature T1 to T2, at T1 equilibrium constant is Kp1, at T2 equilibrium constant is Kp2, and we know K is equal to partial pressure. So integration of dx is x. So upper limit minus lower limit, as in uh, ln of Kp2 minus ln of Kp1. So ln of A minus B will be ln of A by B. So ln of A by B. So instead of equilibrium constant K, I have written pressure. And then what is differentiate? Sir, this delta H upon R is constant, so it will come out integration of 1 upon T square. Sir, minus 1 by T. So upper limit minus lower limit, you will get 1 upon T1 minus 1 upon T2. I hope everybody is clear. I hope everybody is clear. Even Gamer Smith, I hope now you are also clear. Guys, hello, BTW, Emal. Chalo. I hope everybody's clear. Now, moving forward, that means, sir, now we know vapor pressure in and out, but one more thing, sir, you already said that it depends upon the intermolecular force of attraction of the liquid. If the liquid is having strong intermolecular force of attraction at that particular temperature T, it will have less pressure. So what is the basic idea of intermolecular forces of attraction? So obviously these are the different intermolecular forces of attraction, but for your JEE mains, you should just know the strongest intermolecular force of attraction is hydrogen bonding. After that, you have dipole-dipole interaction. And after that, once molecules are non-polar, still they will have some interaction. And those interaction are called van der Waals forces. So if you just know and remember these intermolecular forces of attraction, these three, your job is done. Job for what? Beta, even these things are very famous for JEE, the conceptual side of vapor pressure. So a question is in front of you, giving you 30 seconds to attempt this. Multiple correct. Quick, beta. I need answer. Quick. Everybody. The graph is there. So quick, give me an answer. A beautiful question, rather which brushes your concept. So quick, quick, quick. Chalo, 3, 2, 1, go. So I hope most of you have answered this correctly, because this is obviously option A. Nahi, you have not. Chalo, let's explore this beta. Why? Sir, you have a graph and the following inferences are made on the basis of this graph. Now let us explore this graph. This is X, Y, Z as in three different liquids at temperature T. They must be giving some vapor. So these are the vapor pressure plot. Sir, we know as you increase temperature, vapor pressure will also increase, but not linearly, exponentially. So one thing. Now, if we want to compare, so sir, make one thing constant. Okay, so let us take a constant pressure of, let's say, 500. You can take whatever. Now, liquid X is acquiring 500 pressure at what temperature? Sir, at temperature this, somewhere around 313 in to 333 in between. Liquid Y is acquiring this the same pressure at this temperature. Liquid Z is acquiring the same pressure at this temperature. Sir, obviously we know if liquid X is acquiring the same temperature at a same pressure at a lesser temperature, that means that its intermolecular force of attraction is less. That's why at lower temperature it is providing more vapor. Sir, why it is more? Pressure is same, beta, but it is reaching 500 level at a lower temperature. That guy Z is reaching a pressure of 500 level, but by application of more temperature. That means it must have had stronger intermolecular force of attraction. So who had, so this has strongest intermolecular force of attraction, this has weakest among the three, and this is moderate, sir, intermediate. So let us now go through the options. X has higher intermolecular force of attraction, sir, definitely correct. Incorrect, it is weakest, sir. X has lower intermolecular force of attraction compared to Y, yes. Compared to Y also, Z also, but it is saying Y, so yes. Z has lower intermolecular, no sir, Z has highest, so this is incorrect. That means only option B is correct. That means option 1. Now, they are also tricking you with data interpretation. See, they are giving option B, but in liquid B, but in option, I mean statement B, but in option 1. So most of the student B means 2. So make sure that data interpretation thing, which is actually a CAT thing, in your CAT examination for getting into an IIM, they do the same data interpretation. So I hope you can do it now. Where we can find you every live class, sir? Where we can find you every live class? Yes, beta. Whenever live is done in PW JEE English channel or PW NEET English channel, I will be the point of contact that you will be getting for chemistry. है ना? Chalo. Now moving forward. Sir, now we know, sir, now we are comfortable, sir, now we are comfortable with vapor pressure, sir. So now let us move to relative lowering. So let's do this. Sir, let's say I have a pure liquid. Now I am making this pure liquid as a solution. Why, sir? You have to mix. So let's say I am mixing a non-volatile solute. Now what is a non-volatile solute? Which generally after heating do not creates any pressure. That means it must be a solid. Because let's say you have those sand, if you put that sand in water, will after heating water, will sand will also vaporize? No sir. So because sand is not vaporizing or either boiling, even if you increase temperature, that means sand becomes a non-volatile solid solute. So if in this pure liquid I am adding a solid solute which is non-volatile, then it definitely will become a solution. Now, this is my solution. That means in this solution, I have this sand. I have this sand. Now, you tell me, I'm not heating it. I am just putting it at temperature T. So, sir, at temperature T, let's say this guy, for example, let's say at temperature T, this pure liquid is receiving 100 rupees, 100 joule of energy from the environment, because when environment is at temperature T. So at temperature T, because of receiving that 100 joule of energy, sir, some pressure will be created. Let's say Sir, then equilibrium will reach, yes sir. Then vapor pressures are defined, yes sir. So let's say the pressure exerted by the vapors of this liquid at temperature T, that is the vapor pressure. Let us say that vapor pressure is P naught. So this P naught will be vapor pressure of pure solvent. So this is vapor pressure of pure solvent. Now, sir, you tell me, now you are still keeping it at temperature T. So that means, sir, from environment only 100 rupees is given, 100 joule. Okay. But now, sir, this sand will also take that 100 rupees. Let's say, I'm not saying it will take all that 100 rupees. Let's say it took 30 rupees. So now liquid got less share. Liquid got only 70 rupees. So it will form vapors which will be less, sir, because now, sir, here only also 100 rupees, here also 100 rupees, 100 rupee, all of them took, created vapors. Here liquid is getting 70 rupees, sir, so only proportionally vapors will be formed. This guy took 30 rupees but not doing anything as per the gaseous form. So here, what is the pressure? So this PS is the pressure, or rather vapor pressure of solution. That's why I'm writing S in the subscript. And definitely we know this PS will be less. And definitely we know this P naught will be more with respect to PS. And therefore, I can say what is lowering in vapor pressure? So lowering in vapor pressure by addition of a non-volatile solid solute in a volatile solvent is P naught minus PS. I hope everybody is clear. I hope everybody is clear. And now, if you divide this P naught minus PS with the original value, which was P naught, then you will get the fraction. And that fraction, my friends, is known as, relative lowering of vapor pressure is, let's say, LVP. So this will be RLVP, and this RLVP will be nothing but, sir, it will be P naught minus PS upon P naught. I hope everybody is clear. I hope everybody is clear. Now, thank you, Riti Kash is saying thank you, sir, for nice explanation. My pleasure, beta. Now, Dhana, sir, what is Raoult's law? Coming to it, beta. Coming to it, beta. Concepts has to be revealed sequentially. That's why their essence will remain, and then they will be very easy. So don't rush. Goat, goat, sir. I'm goat. Bakri. Okay, okay. Thank you. Am I very thin or what? Bakri? Eh? Yes, I have lost. I mean, yes. If you ask my mother, she will definitely say I have lost weight. But if you ask my wife, she'll say I eat like animals. Chalo, great explanation. Thank you, Nupur. Chalo, beta. I hope everybody is good now. Now, moving forward. Sir, coming to Raoult's law, a student was asking, and yes, this is the right time to explain Raoult's law. So, Raoult law is nothing. Raoult did an experiment on these liquids forming vapors, and he found, again, beta, this is not a derived law. This is a statistical law, so you have to know this statistical law theoretically, because you will not do experiments while giving your examination. Okay, greatest of all time. Thank you, Kavyan. Acha, okay, okay. Beta, I am a bit not Gen Z, a bit not. I'm very young, but I'm not used to those. What are these acronyms? है ना? Chalo. Now, thank you, by the way. If it is that greatest of all time, so thank you. Chalo. So, GOAT, Raoult's law. GOAT, Raoult's law. Now, what is this Raoult's law? This law states that partial vapor pressure of each component in a solution is proportional to its mole fraction in the solution. Now, what is this law? This law is telling me that for example, you have formed a solution. Like over there, I have used a volatile solvent and I have added non-volatile solid solute. That means I have formed a solution. Now, if I have taken that solution, then this law is telling me that what is the partial pressure. So partial pressure of the solution, which is PS, which is pressure of the solution, will be proportional to mole fraction of what? Mole fraction of each component is proportional to mole fraction of the solution. So what is mole fraction, beta? Mole fraction of what, beta? Partial pressure of the solution will be equal to, why the pressure of solution has decreased? Sir, because you have added sand. The more you add sand, sir, the more amount of sand you will add, sir, pressure is going to decrease. So you don't want that. In fact, you want your mole fraction of solvent. You want more and more solvent. If the solvent is getting more and more increase, then pressure of solution will also increase. So it will be, because we are talking of partial pressure of solution as in the liquid components, a mole fraction of liquid component. And the proportionality was calculated by Raoult's, and the proportionality was the vapor pressure of that solvent in its pure state. So this PS will be equal to P naught X1. Now, sir, we know X1 can also be written as 1 minus X2. So write that. Sir, written. Now, sir, do the math. Okay, beta, doing the math. So I can say this PS is equal to this thing, which is P naught minus P naught X2. Okay, sir. Do more mathematical trickling, sir. Bring P naught here. So I can say P naught into X2 going to that side will be equal to P naught minus PS. Array, sir, divide this. So P naught minus PS upon P naught. Array, sir, this is RLVP. This is RLVP we just derived. And this RLVP is nothing but it is equal to X2. And what is X2? Sir, X2 is number of moles of solute upon number of moles of solution, total moles of solution. That means RLVP is depending upon the amount of solute with respect to solution, and because RLVP is depending only on the amount of solute that you are adding into the solution, therefore it is experimentally given a name that it is a type of colligative property. What is a colligative property? Again, all those property that only depend upon the amount of solute with respect to solution are colligative properties, and hence we have proved that RLVP is also a colligative property. And we have arrived to a very beautiful formula, that is RLVP is equal to X2, which is N2 upon N1 plus N2. Now, for your mathematics, I hope everybody is clear till here. I hope everybody is clear till here. Chalo. Then quickly solve this question for me. Quickly in 45 seconds, an integer type question. So quick, because you know RLVP now. So quickly solve this. Nupur is asking, do you teach class 11th chemistry? Yes, beta. I take Arjuna JEE in English also. I take Arjuna NEET in English also. But yes, I take that in the app, and definitely in the YouTube channel also, beta. You will find my we have done those one shots, so you can find all those class 11 one shots in the same channel, beta. PWJ in English. Just go to the playlist, and I guess we just launched the channel in the previous year in the month of October for the JEE aspirants. So you will find Elevate Crash Course. Just go to the playlist, you will find lectures of physics, chemistry, mathematics, and there I have discussed most of class 11th. So your speech is very soft. Maza aa raha hai. Thank you. Hello, Buzz Edits. Hello, Buzz. So I hope people you are attempting. I hope. Array, time done. So answer for this one is 10. No responses. Maybe the Lens app is not working. Chalo. Let us explore this beta. Now, the question says you have to calculate the mass of non-volatile solute. Okay, sir. That means I need to calculate W2 because solute I mark as 2. Molar mass of solute is given. So M2 is given, which should be dissolved in 118 gram of octane. So because it is dissolved in this, that means this is solvent. So this is weight of solvent. And who is solvents or octane? What is octane? C8, H, 8 into 2 is 16, 16 plus 2 is 18. So 8 into 12 plus 18 into 1. I guess once you solve this, this will come as 114 only. You just check. So that means molar mass of solvent is also given. But you want to reduce to add solute so that the vapor pressure of the solution is reduced to, beta, make sure you read this English properly. Reduced octane, dissolved in octane to reduce its vapor pressure to, okay, this two I'm interested, not this one. It is saying it is reduced to 80%. So initially, let's say P naught value was 100. So now you want PS to not by 80, but 280. So now you want this value to be 80. If it is saying by 80, then it should be, it was 100. If you are decreasing by 80, so this will be 20. So make sure you read that question preposition very properly. Now, so that means P naught also I know, PS also I know. And now we definitely know, sir, from Raoult's law and from RLVP concept that P naught minus PS upon P naught is equal to X2, which is N2 upon N1 plus N2. Now, sir, 100 minus 80 is 20. Sir, P naught is 100. So this is 100 is equal to, because I'm taking ratio, so you can take 100x or 80x. X is going to be getting cancelled. So I'm just doing simply. Number of moles of solute will be, so number of moles of solute can be written as weight of solute upon molar mass of solute. Similarly, okay, so let me write it properly, no? So number of moles of solute is weight of solute upon molar mass of solute. I guess molar mass of solute is given 40 upon, sir, N1. What is N1? Sir, N1 is weight of solvent upon molar. Sir, both are 1. So let me calculate N1 here only. So N1 will be 114 upon 114. That means it is simply 1. So 1 plus W2 upon 40. Now you can definitely solve this. I'm not saying you can't. You can definitely solve this. But beta, that's why for your calculations, whenever you are doing calculations of RLVP, don't use this formula. Why? Sir, because calculation will become difficult. So can we use a mathematical trick? Yes. You can rearrange and you can definitely find this conclusion that P naught minus PS upon PS. Here I'm having PS in the denominator, not P naught. This is RLVP. This is relative lowering of vapor pressure. This is not RLVP because here I have divided by PS, but mathematically why it is useful? Because this is exactly equal to N2 by N1. And that will help you mathematically. How, sir? This difference, you know, 100 minus 80, that means 20 upon PS, sir, it is 80, sir, equal to N2, sir, N2 is weight of solute upon molar mass of solute, sir, N1, sir, it is 1. So this is 1, this is 4, because this is 4, so this is 10, so W2 is quickly 10 grams. I hope everybody get it. I hope everybody get it. Chalo, great. Aditya, sir, I think you are also IITN. Sir, do you teach in dropper batch? Sir, I didn't prepare for JEE in class 11th, 12th. Should I take drop for JEE or not? It is possible to cover whole syllabus in 6 months. So yes, beta, but I regret to say that in English, we do not have a separate batch for droppers this year. But yes, make sure you do all your due diligence, beta. We will be regularly coming live very frequently. And if you are serious enough, na beta, then I have already communicated one thing. Aditya Yadav, beta, in PWJ English WhatsApp channel, we have pushed one shots of all the chapters, including the chapter, the concept discussion, the relevant questions. So you can just do the self-learning approach also, and with these lives which will be coming, we'll be practicing more and more. So those one shots are already there in BWJ English in the Elevate crash course, which was started in the month of October last year. है ना? So make sure you utilize that, Yadav ji. है ना? Sir, should I go to college, sir? I don't have anyone for advice. I genuinely, beta, I'm telling you this. I know truth is bitter, and definitely it is, and I can definitely understand, beta, the situation which you are in is not easy, and rather you are asking it, that too in a platform. So, beta, I really appreciate the amount of courage you have. So the only thing you need is to trust yourself and start preparing, beta. So the content I've already directed PWJ English, the in the live section, the crash course series that we have done the physics, chemistry, mathematics in huge detail, beta. Sir, is this class enough for JEE and ISC? Yes, beta. For mains, it is more than enough. But Yashin Karim, beta, here I'm not taking those advanced topics because this series is valid for all the concepts which are through NCERT and relevant for JEE mains. Obviously, beta, 50 to 55% of advance is also mains. So practically, if you attempt 50 to 55% of it, sir, first, even in your advanced examination, you will have to attempt mains, easy and moderate questions first. So after you have attempted all those easy and moderate questions, let's say 50 to 55% of the paper, you know what is your rank? Your rank is somewhere around 2000. And now you attempt one more question, so the rank will be improved. So first reach 2000. And then definitely, beta, for that you can definitely join us in the batch. And है ना? Chalo, perfect Aditya, perfect Dhana. Chalo, I hope everybody is done. Now moving forward, sir, one more point, sir. We know that this RLB, okay, nahi, we discussed, I've given you that. So okay, this thing, huh? So this formula you should use. Acha, we discussed this, I just forgot. So this formula is not RLVP, but this formula is useful for calculations. I hope everybody is clear. Now, sir, if a solution is following Raoult's law, sir, if a solution is following Raoult's law, sir, then it will be termed as an ideal solution. Now, if a solution is following Raoult's law, now what is this Raoult law? Let's say I have two solutions. Sir, this is a solution A at a particular temperature T forming vapors. So vapor pressure will be P naught A. Sir, again, I am taking this solution, sir. Sir, again, I am taking this solution, sir. Let's say this is different and this is different. Now, sir, this is a solution B, liquid B. And it's not a solution beta. This is liquid A. This is liquid A. Obviously, the intermolecular force of attraction in liquid A will be different. Intermolecular force of attraction in liquid B will be different, and that particular temperature T, they will creating some vapors that will be saturated at that particular temperature T, but this vapor pressure will be different and this vapor pressure will be different. We already know why, because intermolecular forces of attraction are different. Now, let's say if we mix them, let's say this is a bigger bucket where I have mixed liquid A also and I have mixed liquid B also. So if they are mixed, then this is a solution, sir. But this is a solution where I have mixed two volatile liquids. They are not, now this is definitely a solution, but liquid and liquid solution. The previous one was solid and liquid solution. So if it is a liquid solution, then sir, we definitely know from Raoult's law, if you have formed a solution. No worries, sir. What will be partial pressure of A? Sir, definitely at particular temperature T, vapors of A will be also be there. Sir, vapors of B will also be there. So these pink and white vapors are here, and therefore the total pressure, which is pressure of solution, will be equal to partial pressure of A plus partial pressure of B. How you know this? Sir, this is common sense. Total pressure will be pressure of all the gases. Technically, this common sense is given by Dalton's law. Technically, this common sense is given by Dalton's law. And from Raoult's law, we know that partial pressure of A is nothing but when it was alone, as in P naught A, into mole fraction of A in the liquid solution. So it will be mole fraction of A in the liquid solution. Let's say number of moles of A in liquid solution is Na and of B is Nb. So this XA will be nothing but moles of A in the liquid solution upon Na plus Nb. That means these are moles in liquid solution. Similarly, partial pressure of B will be equal to, sir, when it was alone, as in P naught B, into, at this point of time, what is its mole fraction in the liquid solution. How you know this, sir? We know this through Raoult's law. Now, if you combine Raoult's and Dalton's law, sir, if we combine these two laws, what are we going to get? So combination of Raoult's law and Dalton's law will give you what? So Dalton's law has given us PS. So value of PS can be equal to, now you use Raoult's law. So instead of PA, I can write P naught A XA. And instead of PB, I can write, sir, P naught B into XB. So this is one beautiful formula that we have got. Now, one more. Now, one more. Now, one more. What is that one more thing? Sir, even though only people are watching, you are still ambitiously and teaching, sir. Hats off. I definitely see all your videos. I am from Tamil Nadu. Love you for your work, sir. Beta, JEE, DV, you only have given answer. Beta, even I have said that initially only. You know, once we have started this channel in the month of October, we used to have 1-2 people. Now you see the number of subscribers. We are not here for subscribers, beta. Definitely we are this is giving us good so that we can eat properly. The only reason Alak sir has a vision of this English separate funnel is because of the just fact that there are many students, beta. Even last month I have visited Kerala Xylem, the offline unit of PW. Their students come offline. You know what, there are many students in their AI, whatever doubts they are asking, their doubt is segregated from whatever we are teaching at PW, J English and NEET English channel. And once I have met those students, the only language they know is either Malayalam and English. So there are many students all over the place who are not comfortable rather in Hindi or English. So for them, definitely beta, who is thinking Alak sir is obviously there. So we are not here. We definitely know the crowd will be less. But beta, what about those lives? So in order to touch all those lives, this is there. And your comments, I mean, they boost they boost our confidence like anything. So I do not feel like I do not feel like that there are no students. If I'm touching one life, I'm more than happy. 30 to 40 per droppers in IITs, yes beta, that's a percentage. So yes, the although that's objectionable also beta, but yes, around you can say that's a percentage. Chalo beta, let's start. Sanskrit. Jerry, that's a good advice. So we should start a Sanskrit channel also, na? But I guess the number of students, yes, maybe, है ना? Yes, sir. PW is the only source for us to secure good ranks in IITs with reasonable price. Thank you, beta. Thank you, JEE DV. Chalo. So, sir, now we have got a formula for combination of Raoult's law and Dalton's law and all the liquids. Sir, this is a calculated one. This we have calculated. Sir, this you can actually calculate experimentally. Why? How? Arey, come on, yaar, sir. You create a solution, you put a barometer over here. If you are very rich, then you can even use a digital barometer, and this barometer will give you the value of PS. So this PS, as in you make a solution and you calculate this value of PS. Experimentally is easily calculated. So once if you calculate this PS and once you experimentally estimate this PS, so the experimental value and the calculated value came out to be same. So whenever it came out to be equal, those solutions were named as ideal solutions. Those solutions were named as ideal solution. So now we know what is an ideal solution. One more thing, one more experimental thing. Now, what is that? Beta, most of the time your JEE Mains will have this formula and the two formulas that I'm going to. Again, combination of Dalton's law and Raoult's law. According to Dalton's law, we know one more thing. What? Sir, what is the partial pressure of A? So how many, whatever is the amount of pink bubbles, pink dots you have, those will create this total pressure PS. They will contribute. Acha. So according to Dalton's law, because Dalton I have written with green, so according to Dalton's law, partial pressure of A can also be written as what is the total pressure, sir? PS. What are the amount or number of moles of vapors in the gaseous phase? So let's say number of moles of A in gaseous phase is Na dash. Yes, this Na and Na dash may be same, may be different. Generally they are different. Why they will be same? And they can be any value. Let's say number of moles of B in the gaseous phase is Nb dash. So can you tell me what is mole fraction of A in gaseous phase? Yes, sir. Sir, let us write that mole fraction. Let us write that mole fraction as Ya. So Ya will be Na dash upon Na dash plus Nb dash. Similarly, mole fraction of B in vapor phase will be moles of B in vapor phase upon total moles in vapor phase. So remember, these are moles in vapor phase, these are moles in gaseous phase, in liquid phase, and these are in vapor phase. So what is X? I have not written XB also. So obviously XB will be 1 minus XA, which will be number of moles of B upon Na plus Nb. But these are moles of A and B in liquid phase. And sir, which law? So Dalton's law also give us common sense, which is partial pressure of A is equal to total pressure PS into the mole fraction of A in gaseous phase, which we have written as Ya. But sir, according to Raoult's law also we know that partial pressure of A is also equal to P naught A into XA. So beta, this is how you can calculate XA and YA using P naught A and PS. So similarly, you can write for B also. So similarly, you can write this same thing. Rather, let me write it. You can write the same thing for B also, because partial pressure of B as per Dalton's law will be this, and partial pressure of B as per Raoult's law is this. I hope everybody's clear. But beta, you will not get one question. You will get multiple questions from JEE Mains, from JEE Advanced, from NEET, just on the basis of these three formulas: 1, 2, and 3. And these formula will also help you to learn more. What more? Sir, if I have a solution which is perfectly obeying this Raoult's law, then those solutions will be now termed as ideal solutions. Point number 1. So that means, theoretically speaking, all the mixture which follow Raoult's law over all range of temperature and composition are ideal solutions or ideal mixtures. What are the characteristic of these ideal solutions? Whenever you mix them, interaction between AA and interaction between ABB. Remember those intermolecular attraction, because you are mixing them and still, so there is no difference. There is no difference. They are behaving as a single liquid. That means the interaction between A and B will also be interacting because you have mixed them. So all these interactions will be approximately equal. So this is a theoretical important characteristic of ideal solution. I hope everybody is good. So please tell me price of Laksh batch. Beta, all those things are there. I guess that is uh, yes, 4200, but yes, 1100 is added for that infinity batch which Kavyan is saying. But with infinity batch, you will be getting everything. है ना? Chalo, moving forward. Sirs and solute is less than solvent. Dhana, I'll be coming to it, beta. I'll be coming to that dilute thing, but later. Sequentially. Chalo. So this one first point is done. Now, whenever you are mixing two components, if they are having same interaction, that means the enthalpy change, the energy exchange during mixing will also be zero. Once you mix, let's say I've taken 10 ml of A, 20 ml of B, I've added, final volume is 30. So initially total volume also 30, after also it is 30, that means delta V mixing is also 0. But because you are mixing, initially you had only A, now you're having B also. So what is entropy? Sir, entropy is randomness. So if you have increased the members in the solution, then obviously entropy change, which is delta S mixing, will always be positive. Now, what about delta G? So delta G is also a thermodynamic variable which tells us whether a reaction is spontaneous, whether any process is spontaneous or not. Sir, if you are mixing two A and B liquid, so they will be automatically mixed. You do not have to do anything. That means that their mixing is spontaneous. So if a process is spontaneous, then for that process delta G is always negative. So I hope these thermodynamic factors and this theoretical condition you know for ideal solution. Now you tell me, sir, you have discussed intermolecular forces of attraction initially only. If two liquids are mixed, then sir, the one liquid and another liquid is different. That means the molecules will be different. So if molecules are different, sir, how come they will have same? I am not saying they will be having equal intermolecular force of attraction. That's why I have written approximately equal. Because yes, it can be approximately equal. So technically getting an ideal solution in the real nature is close to impossible. Why? Because the two liquids are different, their intermolecular force will be different. How can they become equal? But they can approximately become equal when? Once they are belonging to a same class of functional group. For example, approximately same. So brothers, who are those brothers? So which belong to same family tree. So for us, what is that family tree? The same functional group. So let us list some examples of ideal solutions. So benzene having 6 carbon and that aromaticity, and toluene. What is toluene, beta? Benzene having CH3 branch. So that means they both are aromatic hydrocarbons with just a difference of one small carbon. One small carbon will definitely create some difference in it. More is the size, more is the intermolecular force of attraction, but slightly more. So once you do mix them experimentally, you will see that they more or less form an ideal solutions. So now you have an idea how to identify an ideal solution. They should belong to same category, same class of functional groups. So N-heptane and N-hexane, just one carbon difference, ideal. Alkyl halides are hello. Just what is the difference? So bromine is lighter, iodine is heavy. So a slight difference will be there, but because they are both alkyl halides with same number of carbons, so they can also form ideal solution. Sir, chlorobenzene and bromobenzene, so they are aromatic halides. They will also approximately form ideal solution. But why I'm saying approximately? Because in nature, technically, there is no solution which is perfect ideal. You can have approximate ideal solutions, and hence for your examinations, you should just identify this moving forward. Sir, if solutions are ideal, then we can understand this graphically, because those pressures we have already obviously experimentally calculated. Yes, so let us have that graphical interpretation also. Now, what is this graphical interpretation? A very beautiful graph from NCERT. Now, let's say here in the x-axis I'm plotting mole fraction, but I can plot mole fraction of both. How, sir? Let's say this is mole fraction of A. Okay, it is written beautifully, so let me not make this chi as chi only. So because here chi A is 0, that means here chi B will be 1. because a mole fraction of components in liquid phase, if you add them, it will always be 1. So because XA is 0 here, that means XB is 1. Now, because here at this point XA is 1, so that means XB will be 0. Now, according to Dalton's law, according to Raoult's law, what we know, partial pressure of A is equal to P naught A into XA. So once this XA is 0, once this XA is 0, so partial pressure of A will be 0. So this is 1 point. Once this XA is 1, once this XA is 1, so partial pressure of A will be equal to P naught A. So this is the second point. That means you have joined these 2 points and formed a line, and this line will be nothing but, this line will be partial pressure of A, which is nothing but P naught A into XA. I hope everybody's good. Now, so that means this line we have plotted. Which line? So this one. This line we know now, sir. Okay, beta. Moving forward. Now, sir, similarly do for B also. At XB is equal to 0, this is partial pressure of B. At XB is equal to 1, partial pressure of B will be P naught B. That means, sir, this straight line, which is y is equal to mx form, is nothing but partial pressure of B, which is equal to P naught B into XB. Sir, if you add two straight lines, you will again get a straight line. That means this straight line, the last straight line which I have drawn, is nothing but, this straight line belongs to pressure of solution, which is nothing but P naught A into XA plus P naught B into XB. So that means this straight line is a straight line for solution. And if you experimentally plot this graph and it is exactly coming to the this experimental value, if it is coming approximately equal to this calculated value, this is experimental, so this is calculated. If they are equal, then this represents the graph for, sir, ideal solution. I hope everybody is clear. I hope everybody is clear. Chalo, perfect. Moving forward, sir. Next. Sir, let us, now this is not NCERT beta. This is not NCERT, but let me discuss this NCERT logic. Why? Because after learning this NCERT logic, you can actually understand azeotropic mixture. But yes, this is not NCERT. But it will help you to actually understand the concepts which are written in NCERT, but they are just written theoretically. Now, what are these concepts? What are these concepts? Now, perfect, Kavyan, perfect, Yashwant, perfect. Now, what are these concepts? Beta, the first one is you have to know what is pressure composition curve. Now, this is a pressure. Sir, ideal solution is supposed to have straight line, sir. Ideal solution is supposed to have straight line, sir. We have seen that. Acha, one more thing, beta. One more thing. What if I ask you, I have done some assumption here. What is that assumption? If I ask you just by looking at the graph, can anybody tell me what is the relation between boiling point of A and boiling point of B? I have made a liquid by mixing two liquids A and B. So A and B, they have formed a solution. Because I am experimentally giving you a graph at particular temperature T, although I'm not boiling it, these are just vapor pressure. But still, by seeing their vapor pressure at time T, can you tell me what is the relationship? Can you give any relationship which is, maybe they can be equal, which is greater? Can you give a conclusion? Everybody, just hit the comment section because this is important. So I'm holding for your answers. Anybody? Kavyan is saying boiling point of A is more than B. Ah, yes, Kavyan. Why? Sir, come on, yaar. At temperature T, we have done this initially only. At temperature T, B is giving, when B is alone, how much pressure it is giving? Sir, P not B. At temperature T, how much pressure A is giving? Sir, more pressure. So at the same temperature T, if you are giving more pressure, that means your intermolecular force of attraction is very less. Because your A, intermolecular force of attraction, is very less, that definitely mean it is very easy to boil you. So that means boiling point of A will definitely be less than boiling point of B. And theoretically also, sometimes the what JEE Mains Advanced, they always do it. They they test your understanding, so you should know the logic, the English also, because boiling point of A is less and boiling point of B is more. So how you can communicate this theoretically? You can say B is more volatile. With respect to whom? With respect to everybody? No, with respect to A. And obviously, this will be termed as less volatile with respect to B. This will be termed as, okay, I'm sorry, I'm sorry, because boiling point of B is more, so it is giving less pressure. Na? So volatility is you creating pressure. Volatility is you creating pressure. So that means this you should write here. So that means because A is creating more pressure, so that means it is more volatile with respect to whom? Sir, with respect to Bombay. I hope everybody get that, with respect to B. And obviously that guy will be less volatile. Chalo. I hope everybody is good. A produces, so now you know this volatility thing also. Good. Moving forward. Now, sir, again coming to this, sir, technically for ideal solution, we should only get straight line. You are getting that straight line, but that straight line you are getting for mole fractions in gaseous phase. It can be A also, it can be B also. Only I have written A, it can be A also, it can be B also. We have already seen that. But in because I am taking this mole fraction of A and B mole fractions in liquid phase along x-axis, so proportionally, sir, with respect to xa and xb, I can calculate value of ps. Formula: ps is equal to p naught a xa plus p naught b xb. So for every value of xa and xb, I can get value of ps, and this is my value of ps because I have mentioned them with blue color. So let me draw this solid line with a blue color. So this is the pressure. This is the pressure of solution, and pressure of solution is with respect to A and B. So sir, that means I have got a plot. Okay. So this is mole fraction in liquid phase. This is mole fraction in liquid phase. This blue line represents mole fraction in liquid phase plotted for pressure of solution, which is vapor pressure. Cool. Sir, what is this, sir? What is this, sir? Beta, for every value of XA, for every, let's say my value of XA is something. Let's say my value of XA is this. Okay, this is my value of XA. Let me not take this color, let me take white color. Let's say my value of XA is this. So at this particular XA, I know total pressure. That total pressure will be this. At particular value of XA, I know total pressure PS. Okay, sir. That means, sir, PS is equal to P naught A XA, and proportionally P naught B, because I'm just mentioning XA. So instead of XB, you can write 1 minus XA. So P naught A, P naught B, I know. That means for a particular value of XA, I can calculate this PS. For particular value of XA, I am calculating this PS. This is my pressure of solution. I hope everybody is clear. Now, for this value of PS, can I calculate YA? Yes, sir, because PS into YA is also equal to P naught A into XA. So for this value of PS, can I calculate YA? Definitely, sir. How? Because, sir, you know P naught A, you know XA, and now you have calculated PS. So now for this value of PS, you can calculate YA. What will be this value of YA, sir? Calculated. That calculated value is plotted where? Just at this pressure, what is this value, sir? This value. So that means this is my value of, and that means this is my value of YA, sir. Yes, you can have YB also. Why? Because YA or YB at every time will also be equal to 1. YA plus YB, which is mole fractions of A and B in gaseous phase issue, if you add them, it will be 1. So for every value of YA, you will get 1 minus YA will be corresponding value of YB. So that means this is nothing but this is also for the same total pressure. This graph is a plot. This point I have got, but this is mole fraction of A in vapor phase, sir. I hope everybody is getting. I hope everybody, if you keep on doing this for all, if you keep on doing this for each point of PS and XA, you will be getting value of Y again and again. That means once I have plotted these points, these points, these points, these points, these points, then, sir, the graph that I have got is this. So this is also a graph for ideal solution, which is not a straight line, sir. It is a curve, sir. But this curve is graph of what? Graph of mole fractions of A and B in vapor phase with respect to the total pressure. I hope everybody get that. I hope everybody get that. Hope everybody get that. Eh? Beta, I need yes, because this is good. I need yes. Yes, I can do this more, but because this is how you do distillation also. Because A is having less boiling point, so its vapors will be separated easily. Why? Sir, for this value of YA, you can again calculate. For this value of YA, you can again experimentally check XA. Now with this XA, you can calculate the total pressure PS experimentally. At that value of PS, what is value of Y again? So this is YA. Now at this particular value of YA, you can again extrapolate and get value of XA. For this particular value of XA, you will again get total pressure. This total pressure will give you the value of again vapors. At that, if you convert those vapors again in liquid, again you will get a total pressure, so you will reach here. See, ultimately where you are reaching, so there. That means if I have A and B whose boiling point is less, so boiling point of A is more. So ultimately if you keep on, if you keep on, sir, this solution has boiled, whose vapor will come more? Sir, A vapor will come more because A has less boiling point. So vapors of A collected as YA. Now take that YA and collect it in a separate beaker and now make it XA. As in, now you make it liquid. Now you again boil it. Again bring it to temperature T. Not boil, bring it to temperature T. Sir, it will again form vapors. Whose vapors will again be more? Sir, A. That means you are separating A from B and C. A has been separated. A very, yes, but this becomes quite, because this takes a complete class, but this is the process of separation also you are understanding by this. So I hope everybody is clear. Chalo, now. So that means this is my mole fraction in liquid phase and this is my mole fraction in vapor phase. This is what I have written, vapor and liquid. Let me write this vapor with pink color so that whenever this will get to your end, you can predict that, sir, no, even for ideal solution you can have a curve, but that curve will be mole fraction in vapor phase. I hope everybody is clear. Now moving forward, after this, let us quickly move to non-ideal solutions. Let us quickly move to non-ideal solution. Now what are these non-ideal solutions, sir? The non-ideal solutions are nothing which do not follow Raoult's law, sir. So if you are not following Raoult's law, that means, sir, technically no solution will be ideal, sir. If you add A, B, they are different. So once they are mixed, the interaction between A and B, will never be equal to whatever was between A and B individually. So technically in nature, you only get what solution? You only get non-ideal solution, but very important. How many type of non-ideal solution you have? Two types. Why? Because if you are not following Raoult's law, then how can you not follow it? Once PS is more or PS is less. Experimentally calculated pressure can either be more, if it is not equal, it can either be more or it can either be less. Let's say if the pressure is more, then more as in positive. More as in positive. More as in positive. So if pressure is more, then what should be, sir, instead of this line, you will get more pressure. So how can I draw that more pressure? So pressure will be more, sir. The value of PS that I'm getting is greater than the calculated value. What is calculated value? P naught A XA plus P naught B XB. So this is P naught A XA, P naught B XB. I was expecting this, but actually not, instead of this, pressure was more. So when pressure was more, oil. So why pressure is more? Because A must also be moving away individually. Let me draw this with, because individually pressure of A will also be more and individually pressure of B will also be more. So if you add them, sir, why it is more? Now, let us understand with an example. Let us understand with a very, very famous example. You can take any of these solutions. They are examples of non-ideal solutions showing positive deviation from Raoult's law. Why? Sir, this is acetone. What is acetone? Sir, acetone is a perfect polar molecule, sir. So this polar molecule will be attracting the same polar molecule with dipole attraction, sir. Sir, it is a strong dipole, sir. Plus minus attraction. So one molecule of acetone and another molecule of acetone will be definitely attracted to each other, but this attraction force will be strong dipole attraction. I hope everybody is good. This attraction force will be strong dipole attraction. And once you have another molecule of another type, another liquid, let's say this is carbon disulfide, with this is also liquid, but sir, carbon disulfide is a linear molecule, sir. Although this is polar, this is also polar, but the overall molecule will be non-polar. Sir, do non-polar molecules also attract each other? Yes, because of instantaneous dipole attraction. But sir, that intermolecular force of attraction will be very less. So because it is very less, I'm not using this dotted line. I'm using very, very small dots. So that means interaction between this is very less, interaction this between very, very large. If you add them, so this guy do not like this. Similarly, this guy do not like this. They will run away from each other. It is just like this. You are introduced in a party where you see a person whose face you do not like. And he or she, I mean, you can understand that if you are hating that person, I belong to some other energy, I do not like that person's energy. Once you are introduced in a same party, you will run away from each other. Wherever that person will go taking plate to eat, you will be going to 180-degree opposite direction. If that person is eating ice cream in a party, in a dinner party, you will be going and standing at a stall at a buffet where somebody is doing something else, because you are not liking. So that means individually my escaping tendency will also increase, its escaping tendency will also increase. So individually partial pressure of A will also increase, partial pressure of B will also increase, and therefore total pressure will also increase. So sir, that means they are all example of non-ideal solution. Yes. How to identify, sir? We have to learn them. No, common sense. Three attraction forces I told you: dipole, hydrogen bonding, and van der Waals. So if you belong to different class of attraction force, you will obviously run away from each other. So this is dipole dipole, I've written that also. So this is hydrogen bonded, so strong attraction, weak attraction. Now this is a person like Mukesh Ambani and a person like Gaurav Singh Arora. Whenever, although I mean we have, so I will also no connection. So he's strong attraction force, weak. So they'll also move apart. So whenever you have different molecules, they will always show they will always be a non-ideal solution which shows positive deviation from Raoult's law. I hope everybody's good. I hope everybody is good. Chalo, perfect. Moving forward. Now next is non-ideal solution showing positive. Now some thermodynamic facts beta, some thermodynamic facts regarding non-ideal solution showing positive deviation from Raoult's law. Now, so definitely these two quantities are same. These two thermodynamic variables are same. Why these two thermodynamic variables are same? Because sir, if you add two liquids, sir, delta entropy change in mixing will always increase, sir, because randomness, because you are increasing crowd, so more crowd, more entropy, more randomness. Sir, once you add them, sir, they will still be mixed spontaneously, sir. Even if obviously if you add water, and if you add let's say water is polar solvent, and let's say if you add kerosene, obviously they are immiscible. Obviously they are immiscible. But let's say if you add water and you add some benzene, although they are, but sir, they will not jump out of the glass vessel, sir. They will be still mixed automatically, and all the processes that are happening by their own are spontaneous, and all the processes who are spontaneous, delta G is always negative. So irrespective of you're forming ideal solution or non-ideal solution, delta S mixing is always positive and delta G mixing is always negative. So when you will take haloalkanes and haloarenes, Kavyan, I've already taken that beta. I've already taken haloalkanes and haloarenes in the first class. So just in the live of PWJ English channel, you can go and check. Okay. Kuldeep Meena, yes, beta. I was unable to, because of some technical flaw, I was unable to do that. But obviously, we'll be meeting in the next class. Anna, Kuldeep, great. I hope everybody's good. Kuldeep, good, no? Chalo. Now, what else, sir? Sir, delta H mixing, because you are mixing and they are showing positive deviation. So enthalpy change is also positive. That means if we are mixing two solutions which are showing positive deviation from Raoult's law, and let's say you are holding that vessel in your hand, what sensation you will feel? Cold or hot? I'm asking everybody. If I am holding a beaker in my hand, I have added two liquids. They are showing positive deviation from Raoult's law, because we know if positive deviation, then delta H mixing is also positive. Then what sensation you will feel in your hand? Cold or hot? Cold or hot? I need answer. If I'm not getting answer, I'm not moving. I need answer. Quickly, everybody. What sensation you will feel in your hand? Cold or hot? I'm again repeating. If I am having a solution like that, I'm holding that solution in my hand, I've added component A, component B, they are showing positive deviation from Raoult's law. That means for them delta H mixing is positive. So what sensation I will be feeling in my hand? Cold or hot? Kavyan, I'm waiting. Manisha Gupta, I'm waiting. Cold. Why? When I feel cold, Sir, once the heat from my body will be going inside. When I feel cold, sir, once you hold a cup, and why you feel cold? Because the heat from your body is going inside that solution. And definitely the solution will, what does delta H positivity mean? That means it is endothermic, and definitely because it is taking energy, so it will take energy from my hands now, because my hands will be its surrounding. So definitely I will feel cold. So definitely I will feel cold. I'm not writing it because that's just a question. It will just make your notes uncomfortable, or else you'll feel so why cold. So I hope everybody is clear. Okay. Okay. Chalo. Perfect. Perfect. Everybody great. Moving forward. Now, cold. Obviously cold. I hope everybody got it. Now, what will be delta V mixing? Sir, you already told. If you're mixing, they will run away. I'm not saying they will jump out of the vessel, but sir, slightly the volume will also be increased, sir. So delta V mixing will also be positive. That means if you add 1 liter of both, technically total volume should be 2. So what is delta V? So volume after mixing is 3 liter. What volume initially mixing will be also be 3 liters. So delta V mixing is 0 for ideal case. But here now because they are running away from each other, so final volume will be slightly more than 1 plus 1 as in 2. So slightly more as in, not very more, but yes, 2.01 minus 2, sir, is definitely plus 0.01. So delta V mixing will always be positive. So it will be slightly greater than 2 liters. A very important theoretical points that you should know and you should note. I hope everybody is done. Moving to again. Now this is quite easy, sir. If if the total pressure experimentally obtained is less than as per calculated by Raoult's law, then it forms a negative deviation from Raoult's law. Why it will be negative? That means, sir, the interaction between AB is a strong intermolecular force of attraction. So once you introduce A and B together, they are attracting each other so strongly, so strongly, so strongly that now they do not want to go to vapor phase because they love each other. For example, you have met a person in a party which you, so that's why you will be wherever that person you, so now the pressure will decrease, and those solutions are known as non-ideal solutions showing negative deviation from Raoult's law, where delta H mixing will also be negative, delta V mixing will also be negative, while these thermodynamic quantities are again positive and negative respectively because they are independent. For ideal also, non-ideal also, the later two thermodynamic quantities are always same. Yes, delta H and delta V mixing are negative and positive. And here, if you have a solution which is giving heat, so you will now feel hot. Your sensation in your hands will be hot in this particular case. Now, sir, give us some example. First, let us take those examples. So, for non-ideal solution showing negative deviation from Raoult law, beta, please, 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 for ideal solution, we know which belong to same family. For positive deviation also we know what. So positive deviation are those which are belonging to different set of intermolecular forces of attraction. We can just understand using chemical bonding. But these are the examples, beta. Most of the time JEE tricks you with this. So these are some famous examples which I have collected from all the relevant examples that Mains Advanced have thrown at us. So please learn all of them. है ना? Very important. So giving you example for one, like chloroform. So chloroform is CHCl3. But technically carbon is not electronegative, but because of 3-chlorine, this carbon will be highly electronegative, making this hydrogen highly electropositive. So a very strong dipole. And what about acetone? Sir, acetone is having also polarity, sir. The plus I of this methyl, the plus I of this methyl will give more electrons. Oxygen is also electronegative. It will want this electron, so carbon will become plus. So, sir, now the attraction force that you are seeing over here, this plus attracting this minus, 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 sir, this force is even stronger than the attraction force which this molecule is having with acetone. This is having with another chloroform. So the attraction force between AB is more stronger. And what is this attraction force? This is always hydrogen bonding. So this is, sir, what is hydrogen bonding? Whenever intermolecular force of attraction magnitude is increased to such a great extent. then those simple dipole-dipole attraction are given a special name, and that special name is hydrogen bonding. So please learn all these examples. They will have some special intermolecular forces of attraction, and whenever these special intermolecular forces of attraction exist, you get a solution where the total, why the individual pressures will also be less. Let's say partial pressure of A, because A is also loving B, so it's individually pressure of A will also fall, so pressure of B will also fall, and therefore the total pressure, which is pressure of solution, will also be less than what? So less than the calculated value. What is the what is the calculated value? So this is my calculated value. So here PS, which is pressure of solution, so this is less than what? P naught AXA plus P naught BXP, and this is your graph for non-ideal solution showing negative deviation from Raoult's law. Okay. Said, sir, you are a legend, sir. Love you, sir. Okay. I attended your you NEET day revision live session. Okay, my friend. Okay. I attended you NEET day revision live session, and you brushed up my concepts so well that now I am getting 163. Beta, thank you for communicating this. Thank you for communicating this. All the very best, my friend. All the very best. Every one of us at PW NEET English channel beta, even that we had the same emotions and intent. So thank you very much for communicating this, because these things give us so much of motivation that I cannot express that in words. So your result, that will be a badge on your life journey, beta. But although we have not met, but these things in form of energy reaches us, beta. So thank you very much. Thank you very much. Chalo. All the very best, and God bless for a very, very, very bright future, my friend. Chalo. Moving forward. Great, beta. Thank you. Sir, a very important question now. What you have to do, sir? Just the same thing. What same thing? Uh, d- sir, we will meet on. Yes, yes, yes. So that means you are Syed. Perfect. Yes, beta. Definitely we will. Definitely. Definitely, definitely. My fingers are crossed for the great result that you'll be getting. Chalo beta, quickly an integer type question. So because we have practiced so much of theory, so giving you 1 minute for this. Quick. Integer type answer a JEE Mains question. So please attempt very, very properly. Then we have Sonal Jain. Sir, I am also getting 151 in chemistry NEET. Thank you very much. Oh my God, beta. Oh my God. Great, great. Congratulations. Many congratulations, my NEET warriors. Many congratulations. Sir, yes, definitely, beta. Definitely. Sir, I really like your way of teaching, sir. Thanks for mentioning. Thanks for mentioning that, Sanjeet. Thanks for mentioning that. You do not know how much motivation you uh, put inside us by just writing those lines. So thank you. God bless. God bless. Chalo. So I hope everybody is solving, guys. Quick. I hope everybody is solving, guys. Quick. Chalo. So people are happy after re-NEET. I'm very, very relieved, because yes, that took bit of efforts. But after seeing these things, we are on the seventh sky. So poll is option type. Acha, it is option type. Arey yaar, I'm sorry. Chalo, ho gaya. Just hit the comment section with the answer, beta. I always do this. No, Kavyan? I always do this. I do this in batch also, no? I mean, you people make me remember that, but with time I'll learn. With time I'll learn. Chalo. Now, the vapor pressure of two volatile liquids A and B at 25 degrees Celsius are this and this. That means that this is P naught A. So this is P naught B. Now, if the liquid mixture contains 0.3 mole fraction of A, liquid mixture, that means it is XA or YA, sir, it is XA. Then mole fraction of B in vapor phase. So I need YB. Okay, I do not need, it is also given. So YB is given as x by 17 and you have to calculate this x. Sir, number of times you will get the same question. So Kavyan, great. So let me just, because Kavyan has already solved, just let me just put this. So first you calculate PS. PS will be equal to what? Beta, PS will be equal to P naught A XA plus P naught B. Sir, XB is not given, beta, it is 1 minus XA. P naught B is what? 50 into 0.3 plus P naught B is 100 into 1 minus 0.3, 0.7. So I hope you can calculate PS now. Once you calculate PS, sir, use Dalton's and Raoult's law combination, which says partial pressure of A is nothing. Acha, I need YB. So if I want to calculate YB, so sir, YB into PS will be equal to P naught B into XB. This is Dalton's law, this is Raoult's law. Now, what all things I know, sir, you know everything. So YB will be equal to P naught B, which is 100, XB, which is 0.7 upon PS, sir, you have recently calculated. So let's say the calculated value, because Kavyan calculated, so I'm not calculating. So this is my PS you have calculated, and once you solve, I guess this is coming out to be, okay, Kavyan is saying 14. So it will be coming out to be 14 by 17. So value of X will be nothing but 14. I hope everybody is good. Chalo. So these questions, beta, I've just given you an example. These questions, the same type of questions you get like anything. Now, distillation and all these are good topics. Now, let us quickly move to azeotropic mixture. What are azeotropic mixture? Sir, you know all the solutions in nature are actually not ideal, sir. They are non-ideal solutions. So non-ideal solution can show positive deviation, they can show negative deviation. This does not happen with all the solution. But yes, with few of the solutions which show large negative or positive deviation, for them it has been found in nature that those solutions which show large positive or large negative deviation from Raoult's law, they at a particular level of composition, not at all composition, once they reach a particular level of composition, then at that particular composition, sir, they start to behave like a liquid, same liquid. Sir, if I only have liquid, then what is the mole fraction of that liquid in liquid phase? Sir, if you have just a liquid, if I have just one liquid, so you have only moles of A here. So what will be XA? Sir, XA will be Na upon Na. Sir, it will be 1. Because, sir, this is just one liquid. Okay. If at temperature T it is forming vapors, then what will be mole fraction of A in vapor phase? Sir, let's say I have Na dash moles of A. I do not know what is that moles, but let's say this is Na dash upon total moles. What is total moles? I am listening to some voice. Choo choo. So I guess there is some mouse or what? Choo choo. What? No. Everything is good. Everything AC. I just wanted because I heard it twice. No, nothing. Chalo. Now, so what is YA? Sir, moles of A. See, sound making sound. Okay. CSC vote ki. Acha, okay. So we have critics. So good morning, critic. Thank you for informing. We are very pleased to know that. Chalo. Now, sir, what is mole fraction of A in vapor phase? Sir, moles of A in vapor phase upon total moles. Sir, because you only have A, so this will total moles is also, and that means this is also 1. So technically what I'm saying is, if you have two liquids, but both the liquids, if they start to behave as one liquid, then sir, mole fraction in liquid phase and mole fraction in vapor phase will become equal, sir. And those liquids mixture at a particular composition which are having equal or same value of mole fraction in liquid and vapor phase are termed as azeotropic mixture. Let me again put it for you theoretically. Sir, a binary solution containing two volatile liquids in which both liquid and vapor have same composition. Both liquid and vapor have same composition are called azeotropic mixture. And because although it is a mixture, but at a particular composition, they behave as one single unit, one single liquid. So boiling liquid mixture at azeotropic composition, not always, but at a particular composition, so that we have to learn that composition. Yes, not for many examples, just 2 examples. So at that particular composition produces vapors which has exactly same composition as liquid. So vapors which has same composition as liquids are called azeotropic mixture. Sir, how many types of azeotropic mixture you'll have? 2, because how many types of non-ideal solutions you have? 2. But yes, please remember what non-ideal solutions are capable to form a azeotropic mixture? Those who show large positive or large negative deviation. So what are minimum boiling azeotropes? You can predict it also. Minimum as in they are boiling at a minimum boiling point than their boiling point of the individual components. So when you will boil at a lesser boiling point, what is boiling point? The temperature at which vapor pressure of U becomes equal to atmospheric pressure. That means at low temperature, you are creating more pressure. Sir, who can create more pressure? Which are showing positive deviation from Raoult's law. So minimum boiling azeotropic mixture, minimum will be formed by those non-ideal solution which shows large positive deviation from Raoult's law. So the non-ideal binary solution which shows a very large positive deviation from Raoult's law form a minimum boiling azeotropes, but not always, at a particular composition. And at this composition, liquid and vapor phase are same, X and XB are same, and the liquid boils at a constant temperature which is lower, minimum boiling, than the boiling point of either of the pure components. The only and famous example you should know is example of water and ethanol. You should know this graph. Technically, I have a very beautiful explanation for this graph as well. But yes, obviously that will be some advanced top of, that will be beyond NCERT. So, but yes, those of you who want to just learn them, I have given these graphical plots. You can remember, I have given you that YA explanation also. You can very well have this explanation that, that for ideal solution, this is the plot. For XA and YA, those solutions which have very little deviation from Raoult's law, they can't reach a level. What level? They can't reach a level. This is weakly negative, this is weakly positive. But once you experimentally calculate this graph, estimate this graph for solution showing large or strong negative or strong positive, the graph somewhat becomes like this. And what is this point? So this point I can see the value of XA and YA both are same. See, this is value of XA, this is value of YA. At this point, value of X and Y are same. So at this particular composition, it can behave as a positive boiling azeotrope because negative deviation, and this at this particular composition can form her because this is positive deviation from Raoult's law. This is strong positive. That means this will form a minimum boiling azeotrope. So what example you should know? Yes, I will be giving you this, but yes, it will rather take more time. So let me just quickly give you an example for minimum boiling azeotropes. So famous example is water and ethanol. Water has strong hydrogen bonding. Ethanol has very weak hydrogen bonding, sir, organic compound. So they will not love each other. They will form they will form non-ideal solution showing large positive deviation from Raoult's law. So because more vapors are forming, so it can be boiled at a lesser temperature, which that's why it forms a minimum boiling azeotrope. But at what composition? Once approximately water is 5% and ethanol is 95%. Exact value is 5.6% and this is 94.4% ethanol. Sir, then if a solution is showing negative deviation from Raoult's law, what is that example? Sir, water and HNO3. Water and HNO3. Water boils at what temperature? 373 Kelvin. Nitric acid boils at what temperature? 359 Kelvin. So water and nitric acid love each other because hydrogen bonding, and because they love each other, so large negative. So large negative, that means they are attracting each other like anything. So in order to boil them, you have to apply more temperature. So when they will form as azeotropic mixture, they will boil at a temperature which is even higher than the boiling point of individual components. So they will form a maximum boiling azeotrope. You should learn the value also. So for water this is less, for ethanol for water this is less, for ethanol nitric acid is less, but this solution will have a higher temperature. This is graph of temperature, this is of pressure. Don't learn it for pressure, but at least for your class 12 boards also you should learn it for temperature. So this is the temperature at which it is boiling. And but sir, you can form that azeotropic mixture at all composition? No. So for water and nitric acid, what is the percentage? Nitric acid should be 68% and rest should be water. So 68% of nitric acid in water will form a azeotropic mixture, which will be a maximum boiling azeotropic mixture. I hope everybody is perfect. Guys, okay. Riddhish is saying, sir, you are doing great. Thanks for everything. Sir, you are doing great. Thanks for everything. Thank you, Riddhish. Thank you. Thank you, beta. Chalo. Perfect. Perfect. Moving forward. Now, sir, quickly come colligative properties, and this will, sir, you have discussed so many things, and now coming to beta colligative properties, we already started. We dive deep. We discussed all the relevant concepts also, and that's why it took time. Sir, how we have started colligative property? By defining it. What is colligative property? Let us quickly list it. The properties of solution which only depend upon the number of solutes with respect to solvent and not on the nature of solute are colligative properties. Now coming to the point which one student was saying, because colligative properties are always calculated experimentally, so one, we have observed that experimentally that they are only valid for solutions which are definitely what type of solution? Solid in liquid solution. What type of solution? Solid in liquid solution. So for them, solute has to be non-volatile solid. Point number one. What else, sir? And the amount of solute should also not be very high. If you increase it, then all these formulas will go in vain, because then mathematically, once you see those graphs experimentally, you cannot have that mathematical justification for those graphs. And that's why it is theoretically written for colligative properties that they are only valid for those solutions which are dilute. And what are dilute solutions? Dilute solutions are those where number of moles of solute is very less than number of moles of solvent. And that's why even for your calculations for RLVP, which is P naught minus PS upon P naught, which is equal to x2, which is equal to n2 upon n1 plus n2. Now because we know this experimental justification that colligative properties are only mathematically and experimentally valid for dilute solutions. So that means, sir, this n2 is very less than n1. So approximately, if you are going to do mathematical calculation, you can even write this as n1. But ultimately, you are doing this approximation. So whenever in your question, ABCD options are far enough, you can do this approximation. But sir, once they are very, very close, then do not do this approximation, or else you will be getting an approximated answer and you may take the wrong option. So what you should use? The exact formula. What is the exact formula? P naught minus PS upon PS, which is exactly equal to N2 upon N1. Here I have done no approximation. Here this is approximated. I hope everybody is clear. Now, so that means we know colligative properties also, but you have only communicated, you have only told us, sir, the first colligative property. What about the other colligative properties? Let me, before moving to the graphs, let me give that colligative property to you with ease. I need a slide, empty slide. Now, what I'm saying is, if I have a solvent, okay, sir, pure solvent like water. Thank you. Chalo. So if I have, let's say, if I have just in a beaker, if I have just pure water, you can have any solvent. I'm just taking it for water for the case of simplicity because it is easy to visualize also. Now we know water boil at 100 degrees Celsius. So boiling point of solvent I'm mentioning as TB naught, which is water in my case, is 100 degrees Celsius. Okay, sir. So what you have to do to boil water, sir? Now I'm not evaporation, now I'm boiling. So let's say, for example, for this amount of water, I will give 100 joule of energy, example, and all this liquid water will boil. What is boiling? When the vapor pressure of this water will be equal to atmospheric pressure. So let's say this pressure will become 1 atm. So this pressure will become 1 atm at what temperature? Why? Because at 100 degrees Celsius, I have given this amount of water how much heat? For example, 100 joule. So this guy has taken 100 joule of energy and has formed vapors. Perfect. Now, if I add a non-volatile, remember colligative properties is only valid for what solution? Non-volatile solid. Now I have added this solid solute. That common sense. How much energy, if I'm taking this to temperature 100 degrees Celsius, how much joule of energy I'm giving? Sir, 100 rupees. Out of that 100 rupees, now this sand, this solid will also take some heat. Let's say it take 30 rupees, example 40 rupees. The sand will take 40 rupees, the sand will get heated sand, but sir, it has not contributed to pressure. And this poor liquid guy just got 60 rupees. Initially it was getting how much of rupees? 100 rupees. Because it got 60 rupees, sir, vapors will be less. Sir, you already told relative lowering of vapor pressure, sir. But now I want to boil it again. That means I again want extra vapors. So then give more money. Obviously, if you give more money, this guy will also take and that will also take. This guy will take more, but will again not give. And that guy will require. And now a pressure will come, which is now again equal to 1 atm. That means, sir, if you add a non-volatile solid in a volatile solvent, the boiling point of this solution is going to be greater than 100. The boiling point, of the solution, boiling point of solution I'm writing as TB, will definitely be greater than the boiling point of pure solvent. And the difference by which it will increase, which is delta TB, which will be nothing but boiling point of solution minus boiling point of solvent, is known as elevation in boiling point. Now do the same experiment again. Do this same experiment again. Do this same experiment again. Again take water. But now decrease the temperature till 0 degrees Celsius. So freezing point of pure solvent, freezing point of pure solvent, that means whole of the water has converted to ice. Whole of the water has converted to ice. I hope everybody is clear. Whole of the water has converted to ice. This is ice, sir. Now, in order to convert liquid water into ice, what I have to do, sir, I have to take out energy, heat. Let's say I have placed this in a refrigerator and decrease the temperature. Okay, sir. Again, 100 rupees is easy. So I have taken 100 rupees out of this much amount of liquid water and it has turned ice. Okay. Now, again, add non-volatile solute. So this sand, now how much amount of heat you are taking? 100 rupees. This sand will also give 30-40 rupees. But this was already a solid. It is still a solid. But sir, it has taken energy. I have taken energy, heat from that. So how much of heat, sir? Because 30 I have taken from this sand, which was now it is a cold sand, solid. But sir, poor guy water was here giving 100 rupees and getting solidified. Now 30 you are taking from this, so this guy has only lost 70 rupees. This guy wants to lose 30 rupees more. So now, sir, you have to decrease, take out more heat, sir. In order to take out more heat, you have to decrease, the temperature. So the temperature at which solution will freeze will definitely be less than solvent, and the difference is delta TF, sir. Difference can never be negative, sir. So which is a larger value, sir, of solvent? So this will be freezing point of solvent minus freezing point of solution. Remember this. This is solution minus solvent. This is solvent minus solution. And this difference is called depression in freezing point. This is called depression in freezing point. I hope everybody get it. I hope everybody get it now. But that means if you add a non-volatile solid solute, boiling point gets elevated and freezing point gets depressed, and this is the application which you see in your daily life also. Why you add engine oil in your additives in your engine oil? Why we add additives in your engine oil? Because for example, if I am driving that car in a desert and I've driven like 300 kilometers, then whole of the liquid engine oil will get boiled. I do not want that engine oil to get boiled, so I am adding additive into that engine oil, non-volatile solids. And if you add non-volatile solid to your liquid engine oil, the boiling point of your liquid engine oil as a solution will increase. So elevation in boiling point will help to drive the hell you want. But still, the engine oil will still be in liquid state. It will not boil. What is this application, sir? There are ice in a cold country. You are riding that your car. Not riding. You must have slept inside your room, and the snowfall just took place the complete night. Once you woke up, but you still you just push. Let's say you are rich enough. You have a push start Mercedes. So you push start that Mercedes, sir. But sir, temperature is very less, sir. Temperature is very less. It has the my complete car is covered with snow, but still if you start, it will get started. Sir, why that liquid is not turned solid, sir? Because you have further decreased the freezing point of your liquid engine oil. I hope you now know the application of elevation in boiling point and depression in freezing point. Now, experimentally, once we have observed this, yes, there are some beautiful graphs also, beta. These are NCERT graphs which has told us that this is TB naught. This is TB naught, which is boiling point of pure solvent. What is boiling point? So the temperature at which vapor pressure becomes equal to atmospheric pressure. So this is my boiling point of solvent. If I am adding non-volatile solid solute, so boiling point has increased to TB dash. That is, this is my solution 1. Now this is again a solution. Let's say this is solution 2. So sir, what changed in solution 1? Sir, elevation we know, sir. This is elevation in boiling point. This is delta TB for the first one. But sir, this is delta TB for the second one. Sir, it is more, sir. This we have done experimentally. And we found the more solute you have added, elevation in boiling point increased. So we started experimentally doing it, and then we finally came to a conclusion. And what was the conclusion? Let me use the slide changer. What was the conclusion? So conclusion was the delta TB. Let me not make this notes untidy for you. The conclusion was elevation in boiling point was directly proportional to molality. What is molality? Number of moles of solute upon weight of solvent. So with respect to weight of solvent, if I'm increasing moles of solutes, our elevation was increasing. So we did it, and we saw and we experimentally calculated the value of proportionality constant also, which we have represented as Kb. This Kb is called ebullioscopic constant. It is also called molar elevation constant, which is definitely a characteristic of the solvent. It do not depends upon solute, because this is an experimental law. So you have to know this. Sir, can we calculate this KB for, sir, although this is a proportionality constant, so data sheets were made for every solvent, and conclusion was also experimentally derived that you can even calculate that value of KB, and JEE loves this calculation. So what is that experimental outcome? You can even calculate value of this equilibrium constant, which is ebullioscopic constant for that particular solvent. How to calculate? It is remote square. Don't learn this formula. I mean, this is the same formula. I'm just changing the order because it will help you to learn the formula. How I'm making you learn the formula? Say remote, RMT. What is it? Remote, you know, this is a remote. So remote squared, not complete square, RMT squared. R is universal gas constant, M is molar mass of solvent because Kb is a property of solvent, and T is boiling point of solvent, and only this temperature is squared. So remote squared upon delta H, because during liquid to gas you can calculate, question gives you the enthalpy of vaporization into 1000. So experimental, sir, please explain in Hindi. Gamesy play Z. I'm sorry beta, I regret to say that, but I can't, because read the name of the channel beta. There are many students who are not comfortable in Hindi. That's why we had to have this separate English funnel. है ना? चलो. Now, I hope everybody know this. Now, everything is written. Sir, TB naught is boiling point of solvent. M1 is molar weight of solvent. R is universal gas constant. What value of R you will take? Sir, 8.314 joule per mole per Kelvin. Why? Because this value of delta H will also be given in joule. Make sure sometimes it is written in kilojoule. So make that multiply 10 to the power 3. That this delta is enthalpy of vaporization of solvent, and it has to be in joule. Please put this value in joule, then R will be that. Yes, if you R can even placed in calories, what obviously when you have delta H value in calories, that unit dimension I hope everybody know. Now sir, what about depression freezing point? Sir, again this experimental graph was made, so let us understand this. Sir, this is pure solvent. So what is freezing point? Again, with this graph you can learn the definition of freezing point also. So this is TF naught, which is freezing point of pure solvent. So what is this freezing point? The vapor pressure. What is definition of freezing? Another definition of freezing point, a definition as per vapor pressure. I told you, for all particular temperature you get vapor pressure. Sir, vapor pressure of liquid is more. Beta, solids also generate some vapor pressure, although that vapor pressure is very less. But solids also have some vapor pressure. If you just want to have an idea, just open in the wake up in at around 4-5 a.m. in the morning. In the morning when sun has not came, and then open your freezer. In the month of December, you will see it all the time. Open your refrigerator, the freezer, take out a ice cube, and then see that ice cube in some light. Some light. You will see vapors coming out. That will tell you even solid has some vapor pressure. And definitely solid, yes, definitely very less, but liquid also have vapor pressure, solid also has vapor pressure. And how you define freezing point? Freezing point is that temperature at which vapor pressure of a solvent becomes equal to the vapor pressure of the solid state of that particular solvent. Obviously, the vapor pressure will be very less, and the moment you decrease temperature, vapor pressure will also fall. Sir, it is falling for solvents, liquid state also, it is falling for solid state also. But for solid state, it is falling steeply. There it is falling not that steeply. So this is vapor pressure decreasing. So this is vapor pressure of solvent. This is vapor pressure of that component that when it has turned to solid state. But for a solid also, if you keep on decreasing temperature, the solid vapor pressure will also decrease. So what is freezing point? The temperature at which vapor pressure of solvent becomes equal to vapor pressure of its solid state. Now, this is TF naught. Add a non-volatile solute. Again, draw this graph. So solution 1, we again, sir, now this became my temperature, sir. So the difference will be delta TF1, sir, depression in freezing point, because at this temperature now solutions vapor pressure and solid form of that vapor pressure is getting equal. So sir, this is also freezing point, but this is freezing point of solution. You add more solute, then you will observe that freezing point is further getting depressed. So this is freezing point of second solution. Now this has told you what experimentally, sir, again experiments were done, and again what we found, that delta TF was also proportional to molality. So proportionality constant calculated, KF. KF is called cryoscopic constant. It is also called molar depression constant. And just like KB, KF can also be calculated with the formula RMT square. But here TF naught is the freezing point of pure solvent, because we always write naught. So let me just write naught here also, where TF naught is the freezing point of solvent. Let's say if solvent is water, so its freezing point will be 0 degrees Celsius or 273 Kelvin. Yes, sometimes you can also have this latent heat of fusion. Actually, latent heat of fusion is nothing. Let's say if I have M1 gram, which is molar mass, M1 gram of liquid, then 1 mole of liquid. So for 1 mole of liquid, how much enthalpy you require? Delta H. So for 1 gram of liquid, how much enthalpy you require? Delta H upon M1. And this delta H upon M1 in thermodynamics, it is also called latent heat. So if you are vaporizing, then that is latent heat of vaporization. If you are freezing, then that is latent heat of fusion. So sometimes delta H upon M value is given, but its unit will be joule per or Kelvin per grams. Like for water, latent heat is 80 calorie per gram. So in that time, sir, because delta H upon M taken, so this delta H upon M is replaced by latent heat. I hope everybody is clear. This M is molar mass of solvent. It's the same formula, but yes, you should, and for water beta, you should learn KF and KB. For water, KF value is 1.86, and for water, KB value is 0.52. Unit will be Kelvin kg per mole. So this is for water, and because most of the time you are given KB and KF and KB value, but yes, for few times it is very, very important that you should learn the value of KF and KB for water. I hope everybody is clear. Chalo. Moving forward. Now, what else, sir? Now beta, because you can definitely do all these calculations now. So let me directly move to the fourth and last colligative property, which is osmotic pressure, quickly. So these are all very, very important questions. I'm not saying Doable. Concept of ice separation, we will do once we'll be discussing electrochemistry. We'll be again coming. So over the, before electrochemistry, I'll just finish this few questions also, है ना? Or else. The notes are there with you. Try them. If you find any problem, if you need more justifications, then you have to work now. After the live is done, go to the comment section. The more comments I see, the more I will plan accordingly. But yes, for that you have to now put in efforts after the class is done, not right now. So try them. If you want any more detailing, so now the more detailing will be will be your job. So the more you put in those comments, the more I will be also coming back, Hannah. Now, sir, quickly tell the fourth colligative property, sir, osmotic pressure. Now, for learning osmotic pressure, first you should know what is osmosis. For learning osmotic pressure, first you should know what is osmosis. Acha, beta, let's do this. Let's do this ice separation question and then we'll start it. So that ice concept of ice separation is important, beta. I mean, I was believing, but I was not feeling good from inside. So chalo, let's read the question. Now you know everything. Let's read the question for a minute. Let's read the question for a minute so that I also sip some tea, coffee as in, and you also attempt this, and then we'll start osmosis. No worries. Quick. हाँ यार, it is left. हाँ, come on. Take 2 minutes. Take 2 minutes. By the time I read some of your comments. Take 2 minutes. But yes, try to read the question and try to do that error, because I know you will do one error. But I want you to commit that error, because then it will help you understand questions also. You get direct questions from the formula that I've just said, but this is a better one. Eh? Sir, you have written osmosis in PPT, but you told me it's osmotic pressure. Hey? Arey beta, I will be discussing that senior's approach. I was not telling you. Actually, once you asked na what is osmosis, a student wrote pi is equal to ICRT. So you asked osmosis, and I guess she was there was a girl, hai na? She was writing a very, I mean, very participative. She was. She wrote pi is equal to ICRT. Ankita, yes, Ankita, from the NEET channel. So actually pi is equal to ICRT is osmotic pressure, beta. That is what I was communicating that to her, not to you. To you, I replied, I will be discussing osmosis in the last. Ajit Agrawal, good evening. Tiger, Tiger X Dawn, good evening. हाँ beta, I'm sorry, Tiger X Dawn replied, beta. Why getting offended? Chalo, time is done. I know time is done, but I'm waiting for students to at least read the question, because this deserves time. C. C. Answer is C. Eh? C. Arey, show. Kavyan, great. How are you, sir? Ranveer, Sachdev, I'm good, beta. How are you? Long time no see. Long time no see. Chalo. Let me just read this. Ajit, sir, is NCERT sir, beta, not sufficient, more than sufficient. And yes, few topics like this is not there in NCERT. So then master teaching NCERT is sufficient. And because NCERT is not a book you should read. It is a book you should revise. Once your class notes gets so much super hyped and you are um, maybe amazed, dazzled that sir, or I can't do this much, then you should always go back to NCERT. So that NCERT will tell you you have to read what, and you do not have to read what from your class notes, because that will be valid for advance. So yes, NCERT is a good book to revise so as to understand what is valid for mains and what is valid for 50% of advance, because 50% of advance is also mains. Now, then one more question. Ajit Agrawal, sir, your English is so simple. Even I don't understand English speaking, but your English I understand and follow. From March to prepare April attempt. I am very, very happy to read that, Ajit Agrawal. So Ajit, thank you. These things actually motivates a teacher, but actually you said my English is simple, and I know, even I communicate this in my batches also. Even, you know what, there are many mentors who say, the formula we did know, PS is equal to P naught A into chi A plus P naught B into chi B. I say X A and XB. And there was, I mean, students also, I mean, I started, beta, uh, I was a hardcore offline teacher post COVID. And post COVID, you know what? I mean, pre COVID, not post COVID, pre COVID. Pre COVID, I was an entrepreneur. Matlab, I made, we used to have an offline coaching. People in my district stopped going to quota. We were continuously giving results, and we were taking good amount. Because if they were going to quota, they were also paying more. So for compared to that, we were taking lot less. So got huge, but you know what? Because got very, very huge amount, so invested like anything. So a teacher should never become a businessman. And after COVID, uh, everything got shattered, and then came to teaching, because this is what I know. Thanks to Alak sir, that this platform is now. I mean, I'm still in my hometown, my district, a small place, but I get the blessings of and these responses of you, the tremendous students. And you know what? Everything I forget once we come to this stage, once we are there interacting with 2 3 students only. I mean, I do not even require many students, I just require one student, and then I'm good. But yes, the student should be attentive. He or she should be very much comfortable in actually learning also. And it is you, beta, once you try to understand and synchronize with the teacher, even the language becomes no barrier. What you're saying. And yes, definitely we are not Angrejs. We belong to India, and definitely we can communicate in languages. So my language is Desi, and I communicate in that Desi language, and I like communicating in it. So thank you. Chalo, moving to the next one. Moving to the next one. I didn't know whether that makes some context or not, but yes, I just read that and I wanted to convey this. Come on now, sir. What is this concept of ice separation? This concept of ice separation is very good. Actually, what happens is, if we have added some solute, we know freezing point will depress. Now, let's say if I have added some gram, let's say I have some, let's say I have this water, and I put some rasna. I made some rasna. So rasna will have water and non-volatile solute. And because I know what amount of rasna I've added, so weight of solute I know. So using the formula of delta TF, because I know weight of solute, I can calculate number of moles of solute. So I calculated its freezing point of solution. Now, let's say the freezing point of solution came -2 degrees Celsius. So I set my freezer at -2 degrees Celsius and I place this glass. Now you tell me, if I wake up in the morning and if I take this glass out, will the complete rasna has formed ice cream? That ice cream, you know, na? Baraf gola has that transformed into that ice cream? No. Why? Because, sir, once you reached -2 degrees Celsius, some of the liquid water would have definitely formed ice. You will be getting those ice in the, because ice density is less, so it will definitely start floating. But the in the depth you will again have liquid only. Why? Sir, but freezing point you calculated, because beta some of the liquid solvent has gone. So solvent gone, so that means solute, which is a solid, with respect to solvent has again increased. So that means concentration increased. Sir, concentration as in molality increased, sir. And because molality increased, so freezing point will have depressed to a larger value, sir. So can you calculate the ice that has been separated? That is the question which JEE Advanced started asking, and mains also then follow the suit. Now what is it? You have a solution containing 62 gram of ethylene glycol. This is my solute, weight of solute, in 250 gram of solvent. So this is my weight of solvent that I have taken initially in that glass. I have taken 250 gram of solvent, added this much of solute, and I freezed it till -10 degrees Celsius, thinking that complete water will form ice. But now we know some water will form ice. The remaining water will again become in liquid state only. So, sir, because you have decreased the temperature till -10 degrees Celsius for water, TF naught is 0 degrees Celsius. So, what will be delta TF? So, delta TF is TF naught minus TF. Freezing point of solvent is 0, minus freezing point of solution I have done -10. So, delta TF just 10 rupees. Now, delta TF is equal to, sir, KF into molality. What is molality? Sir, molality is equal to, so this is 10, KF I know it is 1.86, and what is molality? Sir, weight of solute upon molar mass of solute into weight of solvent. Now why I'm writing W1, why I'm not writing 250? Because now I have decreased the temperature till 10 degrees Celsius, so some of the water must have turned into ice. So whatever has turned into ice, that weight of liquid water has turned into solid. So what is the remaining liquid water? So W1 now is the solvent. Now ice is not a solvent, so W1. But sir, molality has this W1 in kg, so multiply this 1000. So this will be actually the weight of water in liquid state till now. Okay, sir, let us calculate it. So you just calculate, I guess this W2 is given out to be 62. If you calculate molar mass of ethylene glycol, so 12 2 ja 24, 16 2 ja 32, plus hydrogen 413 and 6. So 24 plus 6 is 30, sir. This is also 62. So that means this is also 62. So this is just cancelled. So this 0, this calculation is also easy, sir. So W1 will be equal to 186 gram. See, this is JEE Main's question. This is how they are just asking concept, no calculations. Easily cancelled. But sir, how much water you have taken initially? Let's say I have taken 250 ml of water. How much of water? 250 grams. Gram of water. And I have added 62 gram of non-volatile solute. 62 gram of non-volatile solute. Started freezing it. Sir, some of the water must have formed ice. But that ice must have gone up because ice density is less. Some ice gone up. But as solvent has decreased, sir, weight of solute is still the same. But because solvent weight was decreasing, so ultimately molality is increasing. And as molality will increase, more freezing, so more will be depression in freezing point. Because freezing point of depression is more, so that means you require even lesser freezing point of solution. So you can't do it till -10, you have to further decrease. I hope you're getting it. Now, how much, sir, what 250 gram I took at -10 degrees Celsius. How much liquid water I had? 186. So how much water is there? Sir, 186. So how much, sir, weight can't be created nor can be destroyed. So what is ice, sir? What is this weight of ice? So weight of ice will be equal to 250 minus 186. 64. I hope everybody is clear. I hope everybody's clear. Sparsh, I'm sorry, yaar. I can't. Yes. Okay. So again, we have got critic. So Sparsh, welcome. Welcome. If that is the thing, then why you here? Chalo. I hope everybody's clear. Now, chalo. Quickly move. Sir, last osmotic pressure. Sir, osmotic pressure. Sir, osmotic pressure. Now, what is this osmotic pressure? Beta, osmotic pressure is whenever you have a solution and a solvent separated by a semi-permeable membrane. What is the semi-permeable membrane? It is like a sieve, it is like a channi. Once you pass your you prepare your chai, your tea, and once you separate that tea with the ingredients, you use a sieve, you use a channi. And what that sieve does, it allows the chai, the tea, the solvent particles to move through it and not the solute particles, because the sieve size is very small. So with that small size, only solvent can move and not the solute. Now, so what is osmosis? Let us learn osmosis using this beautiful NCERT picture. If I have this solution and this solvent, okay sir. Now if I have, do I have one more picture? No, I have only this picture. Okay, so let's say the height is same. Let's say the height is same. In this side, I have solution. That means I have solvent also. But here I have solute also, because that's why it's a solution. And on that side, I only have solvent. Now, if I separate this using a semi-permeable membrane, this semi-permeable membrane can be natural also, can be artificial also. Natural is those cell membranes, and artificial are man-made, which are generally some inorganic compounds. You should know that because JEE find interest in this also. So artificial SPM are parchment paper, cellophane, and fresh inorganic precipitates. Like what? Like K4FeCN6, those ferrocyanides. So these are some basic examples that you should know. Now, what else, sir? Let's say I have the semi-permeable membrane. Like, what is a semi-permeable membrane? Like a sieve, like a channi, which can only allow solvent to pass through it, not the solute, because pore size is very small. Okay, sir. Got it, sir. Now, because height is same, so you tell me here solvent is more, here solvent is less. Why? Because it is reaching the same height with sand, because solute is non-volatile solid. Because of this sand, the water level will rise. But sir, solvent is less and solvent is more, and you know the basic difference of potential difference. Where you have more solvent, here. Where you have less solvent, here. Solvent will move from where, sir? Everything will move from where? From higher concentration towards lower concentration. So solvent will start to move from the solvent side to the solution side through the semi-permeable membrane. This process is called osmosis. This process is called osmosis. This process is called osmosis. But sir, as solvent will start to move, sir, this level will increase. Yes. And you don't want this level to increase, then what you have to do? You have to stop this piston from moving up. In order to stop, you have to apply some pressure. The amount of pressure that you are applying is pi, because external pressure PATM is here also, external pressure PATM is here also. But because this was coming up, so you stopped it by applying some pressure. You just stopped it. You didn't push it further, you just stopped it. So the pressure that is applied on the solution side to just stop the process of osmosis is called osmotic pressure and written as pi. Sir, if you apply more pressure, then solvent will be forced, then solvent will be forced, then solvent will be forced to move from solution side towards solvent side. That becomes reverse osmosis, your RO machine that you have in your home. So you put on that machine, while switching it on, what happens? So the motor starts working, which apply pressure. So solute, as in as in the impure water that you have. Solvent as in impure water will have some water also, but you want only pure water, not those impurities. So you apply that pressure up from the motor and through the semi permeable membrane. Most of the time when RO cleaning guys come, they charge a lot. They say the membrane is gone. They charge 5 6 7 8 thousands because they say it is choked. Why it is choked? The chunni, the sieve is completely, is if it is completely covered with solid, obviously solid can't pass, but they can choke it. So that's why this is a membrane which is used, and then you get your pure water, the RO water. I hope everybody's getting it. Now we are not interested in that RO. Yes, theoretically you should, I explained, but yes, what we are interested in this pi. Again, sir, experiments was done, and it was found that this pi was also proportional to amount of solute. So because osmotic pressure is also depending upon amount of solute, hence it is also a colligative property. How we have, sir, we have done experiment and we finally found that this pi was proportional to not molality but molarity of solution. And here NCERT writes C, so I'm also writing C, and the proportionality constant becomes RT. So this is your formula for osmotic pressure, which is CRT, where C is the molarity of solution, R is again universal gas constant, and T is temperature in Kelvin. So what is this C? The C is moles of solute upon volume of solution in liters. So the same molarity that it is that velocity. I hope everybody know it. Now, some formulas for you, the RO picture, the fresh water that you get. Now, on the basis of osmotic pressure, you can define isotonic, hypertonic and hypotonic solution. If two solutions have same osmotic pressure, they are termed as isotonic with each other. If students have same osmotic pressure, they are termed as isotonic with each other. A very famous biological example, because these are NCERT examples. If you have red blood cells, the red blood cells in your body, and you put those red blood cells in a 0.9% weight by volume saline solution, the NaCl solution, then, sir, the walls of red blood cells is a natural semi-permeable membrane. The cell walls are natural semi-permeable membranes. That means they will only allow the solvent. Because this guy and this solution has same osmotic pressure, that means you can preserve this red blood cell here, because no movement of solvent will take place, because liquid pressure inside and liquid pressure outside is same. That means it is an example of an isotonic solution. Now we know 0.9 gram per 0.9 gram per 100 ml of solution is isotonic. So let's say if I make it 1%, that means I have 1 gram of NaCl outside. So that means outside solute, let me write solute as 2. So solute is increased outside. So solute increased as in relatively solvent decreased. So solvent outside is less, that means solvent inside will be more. And because inside solvent will be more, that means whatever pressure I will be having inside, that means pi 1, sir, because you have more solvent inside, so solvent will move from higher concentration towards lower concentration. That means your cell walls, your red blood cell will definitely, sir, it will shrink. It will shrink. This process is biologically known as plasmolysis or crenation. NCERT fact, learn it. Now, what can you say this red blood cell is what with respect to NaCl solution? Sir, because RBC generally have fixed concentration. So because I have taken this 1% NaCl solution, let's say this 1% solution osmotic pressure is pi 2. So sir, because you have increased moles of solute, so pi is proportional to moles of solute. So this pi 2 is more. That means you will say that pi 2 is more than pi 1. That means in English you will say this, not writing 2. That means you can say 1% NaCl is hypertonic with respect to what? with respect to red blood cells. I hope you get it. Now, what are hypotonic? Again, if I have 0.8% NaCl solution, it is not 0.9. That means here solute, let me not write 2 or 1 or else you will get confused. Here solute was more, so solvent relatively got less. But this is solute is less with respect to isotonic, so solute is less because 0.8. That means relatively now outside solvent has increased. So solvent has increased outside. That means now solvent will move from higher concentration of solvent towards lower concentration of solvent, and because of that your red blood cell will be getting swelled because water has entered. So what will happen? Sir, cell will swell. Biologically, this is known as hemolysis. That is, sir, because the red blood cell is having extra water, so at time it may get ruptured also, it may get deformed also, it may blow up, burst. So that is rupturing of the cell known as hemolysis. And now theoretically what you will say, sir, the osmotic, the sir, because concentration decreased, so concentration decreased, so pi decreased. So let's say this is pi 2, and let's say red blood cell has osmotic pressure pi 1. What I'm changing, I'm just changing the NaC, the saline solution. So pi 2 is, because concentration is less, so pi 2 is less. So here I will say pi 2 is less than pi 1. That means in English what I can write, in English I can write that this 0.8% NaCl is hypotonic, having less pressure, having less osmotic pressure with respect to red blood cell. So what is a hypotonic solution? Which is having less osmotic pressure. What is a hypertonic solution? Which is having more osmotic pressure than the other one. So what is the other one which we have taken as reference? Red blood cells. I hope everybody is clear. सर मुझे आपकी हेल्प चाहिए, एक प्लीज हेल्प करो, न्यूमेरिकल्स नहीं हो पाते, क्या आप बता सकते हो सीबीएसई बोर्ड के न्यूमेरिकल्स कौन कौन से टॉपिक के इंपॉर्टेंट है? द टॉपिक्स विच आई हैव डिस्कस्ड बेटा, just read this live completely. Crystal of eye separation, wherever I am written JEE mains, so that is for mains. But after this topic, just do NCERT in text question and short example. That's it. For class 12 boards beta, don't even touch exercise. For class 12 CBSE boards, I am telling you, because I have helped so many board students in my offline classes. So I am telling you, for especially your CBSE boards, only do the theory which I am telling you. It is more than sufficient, by the way. And then after reading the theory, only attempt the numericals. What numericals? NCERT solved examples and NCERT in text question. In fact, in text question are also moving one step more from board. So solved examples and in text question, that's it. Sir, I'm Jagdish from Arjuna JEE sir. Do you know me? I'm obviously Jagdish. Yes, but you come very often in the live chat. You come very often in the live chat. So I do not, you don't communicate much, but yes, definitely, because you are telling, but you don't write in the comment section much, I guess. Hai na? Chalo. Now, I hope everybody's good. Moving forward. Then these are some NCERT theoretical applications. Please read this, the biological importance for NEET aspirants and for your class 12 boards. You should read it, but I've written it a very beautiful theory, so you can read. Let me directly come to the last topic. What is this last topic, sir? This last topic is Van 't Hoff factor. What is this Van 't Hoff factor? Sir, because we know if you colligative properties only depend upon amount of solute, they do not depend on nature. So colligative property just saw that what amount of solute you have. Now let us say if I have a solute, say NaCl, let's say I added 100 molecules of NaCl, but now I know the NaCl once goes into liquid water, it forms Na plus aqueous and Cl minus aqueous. It forms Na plus aqueous and Cl minus aqueous. Sir, I have added 100. Sir, 1 will dissociate to form 1 and 1. So 100 will dissociate, sir. It will be gone, sir. And 100 will be produced, sir. Sir, colligative properties do not care that whether you are neutral or you are ions. Colligative property only depend upon amount. So theoretically, I thought I have added NaCl. How many? 100. But experimentally, whatever colligative property you will calculate, it will correspond to 200 species, because colligative property do not even care what is your nature. It only depends upon the amount of solute which has doubled. So value will also be more. People got mad because whatever they were expecting theoretically was not coming out in practice. This madness was revealed by the scientist Van 't Hoff, and he corrected all those equations of colligative properties. So whatever colligative properties we have learned are technically incorrect. They need some correction. So the corrected formulas are, starting with the fourth colligative property, osmotic pressure pi. What is this pi? Sir, let's say this is my experimental value. So this experimental value of colligative property was corrected by multiplying I and then your theoretical value, which is CRT. How delta TB was corrected? So this is my experimental value. It came out to be I into the theoretical value, which is Kb into molarity. What is the second one, sir? Sir, freezing point depression. It was corrected with I into Kf into molality. What is the first colligative property? Sir, RLVP, which is equal to number of moles of solute upon number of moles of solute plus number of moles of solvent. But what you have to correct? Sir, I have to correct number of moles of solute. So I need I only here. Yes, definitely I know colligative property is only valid for dilute solution. So this denominator can also be approximated as N1. So this I will rather not bother, but you should know that in the denominator I has to be multiplied here. But because N2 is negligible, so I into N2 is negligible in comparison to N1. So mathematically it will be N1, but you should know this. Now, this is giving you a conclusion. What? Each time whenever you are calculating I, this Van 't Hoff correction I is what? So these are my colligative properties experimental value. So these are colligative property experimental value. Sometimes in English it is also written as actual value, because actual value is what is coming out experimentally. Upon colligative property, just do this. So this is the experimental value and this is your theoretical value. So it will come to the denominator. So this is experimental Kb into molality is theoretical delta Tb formula. This is theoretical delta Tf formula. So colligative property theoretical. Or rather, you are just calculating it with your formulas. And you should observe in all these formulas of colligative property that since all the colligative properties are actually inversely proportional to molar mass of solute, because everybody is dependent on moles of solute. Moles of solute is weight upon molar mass. So all colligative properties is inversely proportional to molar mass of solute. And now, technically, we use colligative properties to estimate the molar masses of those heavy molecules, those biomolecules, those proteins biologically in forensic labs. So, sir, those molecules have very large molar mass, sir. And because they have very large molar mass, so whatever molar mass we were expecting them, sir, we were expecting whatever masses, like for example, you added NaCl, you know molar mass of NaCl. So you know molar mass of NaCl is 58.5. So theoretically, what molar mass you are expecting, sir? It is the normal value. So that's why sometimes in English, the theoretical value is also written as normal value of colligative property. But whatever you get molar mass experimentally, you feel that this is invalid. So you say that mass, that value as abnormal. So this is just a way of writing in English. So sometimes experimental value is also called abnormal value. This abnormality was corrected by Van 't Hoff now. And because we know colligative property is inversely proportional to molar mass, so this Van 't Hoff correction can also be written as molar mass. So this is inversely proportional. So molar mass normal upon molar mass of solute abnormal. I hope everybody get it. Now, sir, just tell me how to calculate this correction factor. I'm not deriving that correction factor because for your mains, for your board examination, you should just know that corrected formulas I have written. You should just know that how this correction formula can be extrapolated. So first, discussing case of dissociation. Let's say I have a molecule HA. Let's say it is dissociating as H plus and A minus. So let's say at time t equal to 0, this is concentration C, this is 0, this is 0. At equilibrium, this is C minus C alpha, this is C alpha, this is C alpha. So technically, if I write I, then I know I is colligative property actual upon colligative property initial. Now, colligative property depends upon amount or number of solute. So actually, what solute I have? Sir, actually you have these number of solutes. Actually, you have these number of solutes. Theoretically, what solutes you have? These many solutes. So colligative property actual upon colligative property theoretical. So actually, how many solute you have? So this plus this, because degree of dissociation may not be 100%. So this plus this plus this. So C alpha gone. So this will be C plus C alpha. Upon, so this will be just C. So what will be I? Sir, I will be equal to CC gone. So 1 plus alpha. Obviously, you can understand this, that if I have a molecule AN and it is dissociating as N times of A, so now you can definitely predict this. It will be 1 plus N minus 1 times of alpha. So this formula you should definitely remember. If value of alpha is given, put that value of alpha and then you calculate your value of I. How to calculate this N? How to calculate this N? Let's say for NaCl, N will be 2. Why? Because 2 ions are given. For CaCl2, N will be equal to 3. For Al2SO4 whole thrice, sir, 1 aluminum will form 2 aluminum ions and 3 sulfate ions, so N will be 5. I hope everybody can predict this now. One more thing. If you have strong electrolyte, generally for ionic compounds, alpha is not given. And it is not written also it is strong electrolyte, but you should know ionic compounds are completely dissociated. So if you have strong electrolyte, then for them alpha will definitely be 1, although not given. And if, sir, alpha is 1, therefore I will be equal to what? So 1 plus N minus 1. So it will definitely be equal to whatever is the number of ions given. I hope everybody is clear. Now, if sometimes for this weak acid Ka is asked. So for this weak acid, Ka will be nothing, but let me write that Ka over here. For this weak acid, Ka will be equal to, sir, dissociation constant. So C alpha upon C minus C alpha. So it will be C alpha square upon 1 minus alpha. Make sure you apply this formula. But if alpha is less than 0. Or rather, if let us do this, because you can see this mathematically, that if alpha is very less than 1, then you can definitely say 1 minus alpha is approximately 1. Then you can approximately calculate Ka as C alpha square. But this will be approximation beta, which can only be done when electrolyte is actually weak. Once mathematically, writing 1 minus alpha equal to 1 is not bothering. When it will not bother, when alpha will be less than 5%, then obviously you can feel mathematically it won't matter. But else, calculate this. Now, last is case of dissociation. Actually, not all molecules, case of association. Not all molecules associate, but yes, the very famous case you have in NCERT also is carboxylic acid. This CH3COOH, because carboxylic acid, because this guy carboxylic acid, they have to dimerize. Let me make beautiful photo. So this is O, this is O, this is H, and rather this is any carboxylic acid. And let's say I have another molecule. So this will be H, this will be O, this will be C, this will be double bond O, and this will be NER. So obviously we know that, sir, this is delta positivity, this is negativity, this is delta positivity, this is negativity, and this plus minus attraction is nothing but hydrogen bonding. So actually, if you add 100 molecules of carboxylic acid, they associate and become only 50. So technically, carboxylic acid does what? They dimerizes. And because colligative property do not even bother who you are, it only bothers about how many of you are. So in case of association, how will you write I? Sir, it will be 1 plus 1 upon n minus 1 times of beta, where alpha was degree of dissociation. Therefore, this beta will be degree of, it will be degree of association. It will be degree of association. And what is this n? You do not have to bother. If it is dimerizing, so n will be 2. You just put n here. Everything will be taken care of. I hope everybody is good. I hope everybody is good. Sir, you are legend. Sir, class kab tak chalegi? Bas beta. I am done. Now, we have some questions for you to practice. I will be giving all these questions to you, which you can definitely see. These all are questions for you to practice. Yes. The only, acha, this last thing is left, beta. We have not discussed about, although this is nothing. If what is solubility of gas and liquid? This solubility of gas and liquid is nothing but it is governed by Henry's law. What is this Henry's law? What is this Henry's law? Sir, you must have seen that soda water bottle. Why that soda water bottle is only filled till here? Because if you want fizz in your cold drink, then you need those CO2 gaseous molecules inside the liquid. In order to get that fizz, you have to create the proportional amount of gaseous pressure here. So the more, if you just open this cold drink and then sip it and then just close the bottle cork and place that cold drink in the refrigerator, if you keep it out and again drink it in the morning, you will not feel that fizz. Why? Because this is nothing but Henry's law, which says that if you want fizz in your cold drink, if you want this CO2 gas to be dissolved in liquid, then you have to proportionally maintain a pressure of that gas over the liquid solution. So let's say this is the partial pressure of gas that you have maintained over the solution. Henry law mathematically and experimentally proved that the more pressure you had over the liquid solution, the more amount of gas was dissolved. So what is the amount of gas dissolved? Concentration term was used by Henry. It was mole fraction of gas. Obviously, let's say number of moles of gas is Ng and number of moles of solvent is N1. So this mole fraction of gas will be number of moles of gas upon number of moles of solvent plus number of moles of gas. Obviously we know, sir, number of moles of solvent will be very large, and that's why this is approximately 1, because obviously gas in liquid solution is very, very dilute. If you just remove all the fizz, will the cold drink will become very light weight or not, or what? Sir, weight will not even bother. We will only feel that in the taste. I hope everybody is clear. So that means this Xg, that is mole fraction of gas in liquid solution, is equal to n number of moles of gas upon number of moles of solvent. You can practically always neglect this number of moles of gas in the denominator. And once Henry did this for all the gases, he found partial pressure of gas is equal to Kh into mole fraction of gas. So this is approximately same as Raoult's law. The only difference is this value of constant, and this value of constant, this value of kh is actually a characteristic of the gases. So if you have two different gases, which is more soluble, sir, maintain same pressure. So if pressure is same, that means this is constant. So their product has to be constant. So if I am more soluble, then I will have less value of K. So a very important application, that is, if KH of any gas is more, what does this mean theoretically? That gas is less soluble in water. I hope everybody get this idea. Now, with this you are done with Henry's law also. Yes, for Henry's law also you have some theoretical applications, which are, it depends upon nature of gas, temperature. Sir, if gas is HCl, then in water HCl can react also, so it is more soluble. If gas is hydrogen, sir, it will not even react, so it will be least soluble. Temperature, sir, as you increase temperature, gas kinetic energy will increase, it will go away. And whoever gases are more polar, I told you HCl gas will be more soluble because it will react with water. So these are some applications of KH, some questions, some application of Henry law. The soda water bottle, I already told you. Once you are scuba diving, once you go deep inside, pressure of gas increases, so pressure of oxygen, nitrogen also increases. So as pressure increases, more nitrogen will be dissolved in your blood vessels. Once you come out, nitrogen will quickly come out because pressure has decreased. So that's why you feel that thing once you even go for not scuba diving but just swimming, you feel that fizz in you. But once you go to the scuba dive, once you meet those scuba divers, they get a medical condition, a very important NCERT fact. That medical condition is known as bends. That once nitrogen come out with large pressure from their blood vessels, they create a medical condition which is rather fatal for them. So in order to avoid that condition, the air tank that those scuba divers take, it is diluted. It is not complete air. You dilute it with inert gas because ultimately gas is going to be dissolved more. So you add that gas which is inert so that it will not create a fatal condition. And even this percentage is very important. So you dilute that air cylinder that you take during that diving with what? With helium. And what is the actual percentage? 11.7% is helium, 56.2% is nitrogen, and 32.1% becomes your oxygen. I hope everybody is clear now. Similarly, if you go to high altitude, pressure decreases. So less oxygen gets inside your blood vessels, less oxygen you have for your biological system. So less oxygen goes here, less oxygen goes here, you get mad. I mean, that is not a the medical condition is termed as anoxia. You feel that dizziness, and because of that you lose the right choices of making. That's why those mountain climbers, they also take those oxygen with themselves, है ना? So these are some applications, these are some basic questions, but yes, you have to practice them. Once you practice them, whatever you need extra, because obviously covering this huge chapter in one shot is a challenge. I accepted that and I tried to justify that, but yes, you will definitely require more of efforts from a particular area. Then you know what to do. Just go to the description section once the live is done, and as you go to the description section, you can communicate whatever doubts you have. I will be definitely watching those comments and will be giving all the relevant queries regarding that, है ना? So this is it. Thank you, Kavyan. Oh my God, Kavyan, you have been from the start till the end. So thank you. Great. All the best. But please work accordingly. Sir, आपको नींद नहीं आ रही? Nikita? Yes, definitely, because tomorrow I have to leave also in the morning. So yes. Nikita, चलो मुझे, हाँ चलो. Thank you everyone. Thank you very much. This is it. Gaurav Singh Arora signing off. Bye bye. Take care. We'll see you soon. Bye.